गुड मॉर्निंग सर, अरोड़ा साहब नमस्कार।
Good morning, Dr. Arya. Good morning.
Good morning, Dr. Arya, Dr. Rai. So, shall we start today's program? This is the last day of the 3 days national training program organized by Academy of Natural Resource Conservation and Management. So, at the outset, I'll listen the participants 3-day program. I request the course director, Dr. Pradeep Kumar Rai, to kindly introduce the first speaker. And as per the program, we have 3 lectures, and after that followed by discussion, and there will be evaluation quiz for participants on the basis of the 3 days lecture, and thereafter we will be having a valedictory session with our chief guest, Dr. Pradeep Dey from Indian Institute of Soil Science, Bhopal. So, all the participants kindly mute while entering the meeting. Thank you, and I request Dr. Pradeep Kumar Rai to kindly start the readings of the today's program.
Thank you, Dr. Arora. Very good morning to all of you, and welcome to the third day of this training program. Today we have with us Dr. Vivek Manohar Arya, and he will deliver his talk on the carbon sequestration and soil health. So it is a very burning and interesting topic. So Dr. Arya, Dr. Vivek Arya is a soil scientist working in SCOS Jammu since 2006. He has been a dedicated teacher, researcher, and worked extensively on soil-based field research programs. His area of specialization is soil quality, climate change, and natural resource management. He had developed and successfully implemented many soil conservation models in the Kandi area of lower Shivaliks. He had popularized soil quality and water productivity enhancement models for rain-fed horticulture also. He had worked in the extension system and successfully popularized the natural resource management practices and climate-smart agriculture practices. Dr. Arya popularized the real-time nitrogen management through the uses of LCC, that is leaf color chart in J and K, which can reduce the losses of nitrogen. LCC distributed by the SCOS Jammu is popular among the farming community of the area. And Dr. Arya had adopted various scientific interventions on pilot basis for revival of village pond in lower Shivaliks of Jammu region. The water conserved in ponds is catering the domestic needs of the villagers for growing crop, vegetables, and fruits. He had demonstrated about the uses of various resource conservation technologies. He is handling 4 externally funded projects with the thematic area of soil quality, climate change, and natural resource management. Dr. Arya has written more than 25 research papers in the reputed national and international journals. He had authored 2 books, many book chapters, and more than 30 popular articles. He had guided many PhD and PG students. Dr. Arya has been awarded with various prestigious awards and at international and national level. And he is associated with many government agencies regarding climate change and soil and water conservation practices. So, and he's also working with various organizations like DST, DBT, and ICR, NABARD, and JKDST. So, keeping with his vast experience and I request Dr. V.M. Arya to please deliver his talk, the carbon sequestration and soil health management. Dr. Arya, please. I request the participant to kindly mute their mic.
Sir, my screen is visible to you?
No, not right now. Yeah, now I started sharing.
अभी हो रहा है शेयर?
अभी नहीं.
ये क्या प्रॉब्लम हो रहा है? थोड़ा गाइड करें मुझे आप. शेयर स्क्रीन में मैं जा रहा हूँ.
शेयर पहले ओपन कर दो ना अपनी स्लाइड आप.
स्लाइड मेरी ओपन है.
और फिर शेयर कर दो आप.
ये तो शेयर है.
नहीं, शेयर स्क्रीन दबा के क्या दिख रहा है उसमें?
सर एक वही शेयर स्क्रीन करके, हाँ, इंटायर स्क्रीन.
ना एंटायर स्क्रीन कहाँ? वो तो आपको अपना टाइल दिख रहा होगा ना उसका,
एक मिनट
जो खुली हुई चीज है वो दिख रही है, जो पावर पॉइंट।
सर, एक मिनट एंड शो करके मैं एक बार करता हूँ।
हाँ, क्या कह रहे हो?
अब आ रहा है सर? मेरे को तो दिख रहा है सर।
नहीं आ रहा।
ये तो पंगा है।
आप
क्यों आ रहा है सर?
तो अरोड़ा सर को मेल कर दो अभी आप।
किसको?
अरोड़ा सर को,
आपको करूँ मेल?
अरोड़ा सर को कर दो आप।
अच्छा, मैंने किया है सर मेल अरोड़ा साहब को।
ठीक है।
So meanwhile, sir, at the outset, I am highly thankful to the ANRCM President Dr. A.K. Singh, Dr. Sanjay Arora, sir, and course director of this training program, Dr. Pradeep Kumar Rai, that they came up with this idea for organizing 3 days training program. And being a part of this training program, I am very happy to share that we have crossed almost 220 participants actively. And from the last 3 days, people have shown great interest, right from student to the higher ups like Dr. Patra, and now you are saying that Dr. Day will be joining us. This is indeed a very great milestone for ANRCM having a very small journey. And I am highly thankful to the dedicated team sitting across at Lucknow that they are coming up with various ideas or on organizing such training programs which will be the need of the hour, which are the need of the hour for like soil health management concept and practices. So I have been given this topic that carbon sequestration and soil health. Uh, Over the years, this carbon sequestration had gained a little momentum across the globe, and the people from, you can say, across the world, they are working on carbon sequestration. But now with various new studies, and we have organized one new lecture, a lecture by Dr. NP Datta Memorial Lecture in Indian Society of Soil Science, and we came with this we came with an idea that carbon sequestration is very easy to say, but it is very hard to sequester the carbon, especially for longer term. I request the host to kindly share my screen. I have mailed them my presentation. Some technical issue is being coming here, that carbon sequestration and soil health. If we go by the topic, that this comprises of two topics, that is carbon sequestration and soil health. Yesterday also Dr. Aziz, he had given a very lengthy lecture and very elaborately he had described what is soil health. Next please. Next. Why soil health is important? Because the birthright of all living thing is health, and it is equally true for soil, plant, animal, and humans. And the health of these four is a one connected change. We have to understand that earlier we were thinking in isolation that what is soil is an inert material, and over the years now we are realizing that soil is a very important component of our all ecosystem. And you must be knowing that even the religious people like Sadhguru, they are making people aware about the importance of soil, because existence of the human or totally dependent upon the soil. We cannot grow artificially soil in the lab, and whole of the food system is coming from the soil. So healthy soils makes healthy crops and healthy people and healthy societies. So these are all interconnected things which we cannot think in isolation. So whosoever, whether they are rich people, whether they are healthy people, whether they are a healthy nation, whether they are well nation, they have to you can say protect their soil for their betterment, because once the soils are deteriorated, it is impossible to retrieve them permanently. So we can say that there is an interconnection between the different, you can say, component of the society. That soils is ultimately the pillar of the society. Healthy soils are the essential component vis-a-vis the development of the country is concerned. Sustainable agriculture starts with the soil by making improvement in the soil physical structure and organic matter content, water holding capacity, and nutrient balances. Many agriculture systems are under threat because soils have been damaged. You take the example of Indo-Gangetic Plain, that there was a time when we have tried to apply this NPK on the higher side, and we went to the monoculture, and now the results are in our, you can say, results are now clearly depicting that the soils have reached a fatigue point where there is no response of the fertilizer, and even the soil biological properties, physical properties, and chemical properties, they are on the lower side. These are few of the, you can say, the challenging areas where all the soil scientists or the natural resource management people have to think. Next. There are two terms which are being interchangeably used. This is soil quality, which is mostly favored by the soil scientist, and there is one soil health, which is favored by the farmers, tend to be used interchangeably. Characterization of soil quality by scientists focus on analytical part, like what we are trying to describe in physical, chemical, and biological properties, which are sometimes called as indicator. Whereas the soil health can be described in a descriptive way by the farmers, that my soil is healthy, it looks very nice, they are having a good porosity, he can touch the soil and he can feel the factor that the soils are good. There can be change interchangeably, but more appropriate term will be the soil quality, and this term was first given by the Indian Society Soil Science Society of America in 1994 by Dr. Corland and his co-worker. Next. Long-term management of soil to maintain productivity either through an adequate nutrient supply or maintenance of good physical, chemical, and microbiological condition is a challenge in itself. It is very easy to say that we have to maintain a threshold value where we can come to a conclusion that up to this level we can extract the soil and we can get the productivity. But in practical term, it is very impossible for any science scientist to come with an idea that this is the exact focal point from where we cannot go upward for productivity. And self-contained is the challenge is the maintenance of the soil, as when unlike in the past, the soil is being amended with large quantity of fertilizer. Earlier we were using large quantity of fertilizer for production. Now with the help of, you can, instrumentation, and with the help of long-term experiment result, we came with the conclusion that soils are being deteriorated and soils are getting the side effects of the excess use of particularly one type of nutrient, or you can say the skewed ratio of fertilizer. Next, please. Similarly, there is one book which created, a lot of noise among the soil scientists. That was the Managing Soil Quality Challenges in Modern Agriculture, and the PDF of it is available. I request the students, especially who are in the audience, to kindly download this book. It is a very good book, and it was recommended by Dr. Bijay Singh in one of the training, that is Managing the Soil Quality Challenging in Modern Agriculture. You are having a 7 billion of population. You have the pressure of building, you can say, uh, infrastructure where you have to feed the 7 billion people, and on the same hand you have to maintain the soil. Next, please. So this book will be a very helpful for the students especially. Similarly, concept of soil health cannot be considered, in isolation. I told earlier, most of the contributor found it difficult to identify the critical threshold values that would allow maximum production while minimizing any deterioration in the soil health. Therefore, the challenge ahead is to understand how fertilizer application is influencing the soil health, and in turn how fertilizer management need to be modified. Say for example, we are you talking about the integrated nutrient management, or we are saying that in the coming slide we will be showing that we are saying that no tillage. These are some of the operational aspects where the soil scientists can work along with the agronomy people, that they should come with a clear cut roadmap, that what can be performed in the field, so that the quality of the soil, that the quality of the soil means the physical, chemical and the biological properties. And in terms of that, what we are saying that indicators become the threshold, and we should come with a clear cut idea that we should not cross that limit for our productivity, because ultimately in coming years it can deteriorate the soil. Next please. And one of the most important component over the years which I have learned from Dr. Sanjay Arora, Dr. Vikas Sharma and my seniors, that soil learning matter plays a very pivotal role vis-a-vis all these properties are concerned, whether physical, chemical and biological, because due to the fundamental coupling of microbial carbon and nitrogen cycling, the loss of soil organic carbon has serious implication for the storage of soil, and soil nitrogen is very important. I will be coming to the sequestration part earlier, but I have to make you understand why soil organic matter and soil nitrogen are important vis-a-vis carbon sequestration is concerned. The loss of organic and decreases soil productivity and the agronomic efficiency of the fertilizer. It is known to everyone. Since soil reserve usually supply the bulk of an uptake by non-leguminous crop, a decrease in the soil and supply is inherently detrimental to the productivity. Although the cereal yield may forward time to be sustained, like the example of Punjab and Haryana, but ultimately we came to a effect that is called as the plateau effect, where we will come to know that there will be no further increase in the, you can say, fertilizer if you apply only nitrogenous fertilizer or the NPK. So we should have to think in a way that how we can store the soil organic matter, or we can say specifically how we can store the carbon in the soil, because carbon forage and alliance between different nutrients, you can say it is a alliance partner along where all the physical, chemical and biological properties they use to interplay. So soil organic matter a key indicator for soil, and you see it is very alarming that the average rate of loss is 25.3 million tons per year, and it is 300 million tons per year during the last 300 years, and it had crossed almost 760 million tons during the last 50 years per hectare. And these are all owing to anthropogenic reasons like tillage, one of the major culprit where the carbon is being lost because I will be showing a slide. The paper was published in Nature. I have taken from Devashish's lecture. He has shared with us, where we can clearly say that the disturbance of the structure creates the carbon to break down into a form which is easily oxidizable. And disregard to the restorative management practices like use of cover crop, perimeter runoff control, and other measures. Next, please. And these are we all are aware, what are the major greenhouse gases like carbon dioxide, methane, nitrous oxide and other, and all of these components, all of these major greenhouse gases, they are coming from the agriculture. So we cannot escape the responsibility vis-a-vis climate change is concerned. Earlier there were two school of thought that climate change is a myth. Now with the onset of these all technologies, and when the scientists of high caliber like Dr. Pathak Saab, they have reached to the ICR top directorship, they were saying this from the last almost 25 years, 26 years, that climate change is a reality, and agriculture is a big contributor to the, you can say, climate change greenhouse gases. Next, please. I'm extremely sorry that Arora Saab is doing this slide sharing, but due to this technical flaw, I am not in a position. Next, please. So, one of the myth this slide is particularly for the student, that we used to discuss the greenhouse effect in a very negative way. We have to understand that greenhouse effect is essential vis-a-vis climate of the earth, the atmosphere of the earth is concerned, because if there is a no greenhouse effect, the sun rays will directly come and it will reflect down on the earth surface, and it will go directly back to the atmosphere. It will not have that impact of warmness which is essential for the existence of the human race as well as for the biodiversity. So you can say that the greenhouse gases, they are required, and the greenhouse effect is required. But the problem is, over the year, because of this anthropogenic activity, it has increased manifold, which is damaging the ozone layer, which is ultimately leading towards some of the side effects. So you can say that once you are writing in your paper like or you are discussing the greenhouse effect, you cannot always say that it is a negative effect. It has played a positive impact vis-a-vis evolution of earth and evolution of human race is concerned. Next, please. Life depends on the greenhouse effect. You see that the Mars have a very thin atmosphere with a weak greenhouse effect. Its average temperature is minus 55 degrees Celsius. We cannot survive. Similar, Venus has an intense greenhouse effect. Its atmosphere is thick with carbon dioxide, and Venus is much hotter than Earth, 462 degrees Celsius. That is what I am trying to explain. That greenhouse gas effect is mostly discussed in a very negative way. Students, especially, they should understand it is important for the atmosphere of the Earth. if it is there, if there is no greenhouse gas effect, otherwise it is very possible. See, but the problem is over the years you will see in this graph that carbon dioxide and nitrous oxide and methane, which are coming from different sources along with the agriculture, they are on the increasing side. We have reached almost 400 ppm vis-a-vis carbon dioxide concentration is concerned, and that is almost you can say in the last 100 years. Running, please. Next. So these are few of the things where we can work. Next, sir. Next. And agriculture, being a contributor, it almost comprises of 11 to 12%, and forestry contribute 12 to 20%. Combined, we can say it is almost equal to 30 to 35% of contribution of the agriculture, you can say, gases. Next, please. Next. What are the different impact? India being 70% land drought prone and 12% to the flood prone and 8% to the cyclones, climatic stress and calm are very common in Indian agriculture. Frost is very common in northern region, and frequent episodes at many places. You have seen in the this year also the heat wave. Similarly, the frequent flood situation everywhere across from Bihar to Uttar Pradesh. Even few days back there was a flood in Bangalore. These are all, you can say, the extreme weather events which are clearly indicating that the climate change is a reality, and India being a country having a diverse agro eco region will be facing this huge challenge of climate change. Next, please. And you see the pictures where we are having a picture which clearly shows about a drought condition, and another picture in the same slide where it is a submerged condition. Similarly, the ruminants, the rice field, manure management, and residue burning, these are all sources of methane in agriculture which are coming directly, and people across the globe now they are working on certain modules. They have developed certain modules where they can reduce these emissions from the soil as well from the ruminant, which we'll be discussing in the coming slides. Next, please. Everybody knows emissions of the methane from the soil directly. It comes in the form of CH4, and even you see this, the decomposition of soil organic matter is also responsible for the emission of the methane from the soil. Next. Sources of nitrous oxide in agriculture, soil and fertilizer is a big source. Similarly, the manure management, which Dr. Vikas Sharma sir, my head of the department, he was discussing yesterday, that there is a lot of emphasis on the organic agriculture across the country, but we have to be a little bit realistic that whether we are in a position to feed the population which the India is having, and whether organic farming is responsible for reducing the carbon footprint, which papers are little bit more confusing. They are saying that you can say the emission of the gases from the organic sources are a little bit more as compared to the integrated nutrient management. Next, please. And this is the nitrous oxide emission from the soil, which is very clearly depicting this reaction that volatilization is there, denitrification is there, and leaching and leaching has led it has led to the problem of the, you can say, polluting of the water aquifer, especially in Punjab and Haryana and some part of Uttar Pradesh area like Bathinda. The water is not even, you can say, drinkable after using, you can say, any sort of instrument like water purifiers. Next, please. These two slides are very important, and there are a lot of, you can say, discussion going on that what is the fate of the fertilizer for the nitrogen in vegetarian case, and what are the fate of the fertilizer in for non-vegetarian case. I am not here to recommend any sort of, you can say, recommendation, but this is the paper which was given by Galloway, and if you see the picture, it is clearly saying that if you are a vegetarian, out of the N produced, if it is 100%, 14% of N produced in the Haber and Bosch process enters your human mouth directly after being passing through different passes like nitrogen being consumed by nitrogen in crop, nitrogen harvesting, nitrogen in food, nitrogen consumed. So ultimately 14% is coming. Next slide you will see that if you are a non-vegetarian, you will see that only 4% is coming to you, rest is going across to the atmosphere. And there was one paper, there was a conference being organized by Soil Conservation Society of India in Jammu, where Dr. Ladda, he had presented a paper, and he was saying that from the last 100 years we have catapulted a data, and we are not sure about the 60% of the nitrogen which has gone into the atmosphere somewhere which we have not quantified. So these are few of the challenges where we have to work as a scientist, that how we can increase the efficiency of the nitrogenous fertilizer, how we can sequester the carbon. Next please. Impact of climate change on soil. Next. Soil health, as the topic was saying, what will be the impact of the climate change? The temperature will increase, the oxidation process will increase, greater evapotranspiration, which is also a negative side effect, soil water deficit, increased salinization. Salinization is a huge challenge, especially in the coastal areas and part of India, and even under the UN, United Nations Development Goals, soil salinization is one of the developmental goal. Similarly, more mineralization, although mineralization process is good for soil scientists, but more mineralization means leading towards vulnerability of the nutrients towards more losses. Similarly, you can say these are all things which will be impacting that soil become drier, reduce productivity, water increase demand, reduce supply, pest will increase, production reduce, crop yield, livestock. Recently the lumpy disease, you can see one viral disease, it had shackled the economy of our country, and all the state government across, along with the central government, they were in a hurry. These are all things which are coming directly towards us because of the change in the climate, because of the change in our biodiversity. So that is why, being agriculture scientists, we should take into mind that what steps, what agriculture modules we are going to adopt. Next please. Yes sir. So this particular field is having a potential to see that how much organic carbon pools we can store up to 100 centimeter of soil. Although we are 70% rain-fed agriculture in India, but fortunately the data is saying that we India can sequester more of the carbon because of some certain practices. Because if we incorporate certain good modules, agronomic modules, like use of the cover crop. Recently we have concluded one study at our center, where we have depicted that using of cover crop along with the resource conservation technologies, they are having the capacity to store more carbon. Although the carbon, we have not quantified the form of carbon, which carbon is labile or non-labile carbon was stored, but the total carbon was there more when we are using the cover crop and leguminous crop across with certain resource conservation technologies like a perimeter runoff control. Next please. There is a new and stronger evidence that most of the warming observed over the last 50 years is attributable to the human activity. This statement I am just sharing with you. This is the latest statement which was shared by the Intergovernment Panel on Climate Change in 2021. So warmer, we are moving toward warmer climate, means warmer, more oxidation, more losses of the carbon. Next please. सर आप रनिंग करते जाएंगे, मैं रीड कर लूंगा. These I have already discussed. I can skip this. This is the soil organic part is of the global pool. You can say in the gigaton, atmosphere it is 750, soil में 1400 है, soil inorganic form में 930, and living vegetation में 760 है. The amount of carbon in the soil of the earth is about 3 times the amount in the atmosphere. So soil can work as a sink. We have to understand that soil is having a potential to sequester carbon, because we have to. There are two terms which are very important for, especially for the new audience, especially the student. There is one source and one sink. So soil and ocean, they can work as a sink for sequestering the carbon. Carbon dioxide removed from the atmosphere of a plant by photosynthesis, and plant material converted to organic matter through microbial biochemical reaction and stored in soil is called as carbon sequestration. How much carbon you can store into the carbon over and over by incorporating, you can say, the residues or the litter fall. This is sequestration. And now the point is that now the scientists are saying that how much is the potential. And recently we when we listened to Dr. Devashish, he came with a very clear meta-analysis of the data across from the globe. He said that the potential of the soil is very much there to sequester the carbon, but question is that which form of the carbon is important, and where we are storing the carbon, whether it is in the upper layer or whether it is in the lower layer, whether it is in the micro aggregate, whether it is in the macro aggregate. Next please. Similarly, this is very important for everyone, that we are using their one term, that is 4 per mille. that this was given by Min Seni et al. In 2017, and this paper was published in Nature. I have taken this slide from Dr. N.P. Datta Memorial Lecture. This particular term 4 per mille is coming because the annual global carbon dioxide emission from fossil fuel is 8.9 gigatons, and it is equal to 2400 gigatons of soil organic carbon stored in the soil. And if we divide 8.9 by 2400, we get the 4% value. So this is very important for all the young you can say scientists, that how it is how we are using this term 4 per mille, and we have seen in many papers it is coming from this particular equation, that 8.9 divided by 2400 gives us 4%. That is 0.4% increase of soil organic carbon per year is the threshold value which scientists across the globe, big scientists like Dr. Ratan Lal, Dr. Sanjay Arora and other people, they are saying that this much carbon we have to store in carbon if we want to come up with sequestration of the soil is concerned. Next, please. So this is the principal biome. I will not go into detail. These are the organic carbon biome and inorganic carbon biome. If you see the inorganic part, it is very important for Rajasthan and the area of Asian countries like arid and semi-arid region. That's a lime deposit. And if we go to the organic carbon part, these are savannas, prairies. Even in our area, we can say the Pir Panchal, the Himalayan regions. They are the area where we can sequester. There is a huge potential for sequestering the carbon. Next, please. One very important definition which I want to share with. There are many different definition, but what I have chosen from the IPCC and that one particular agency which is dealing with this particular is the carbon sequestration is essentially the process of transforming carbon in the air, that is carbon dioxide and carbon dioxide, into store soil carbon. Carbon dioxide is taken up by plant through the process of photosynthesis, everybody knows. But now the problem is that what I have discussed with you, that how much carbon we can store and where we are storing, and what is the form of the carbon, whether they are labile, whether they are non-labile, whether they are easily oxidizable form of carbon. These are few of the challenges which we have to work in the coming years. Next, please. Next. Next. This is the global carbon flux budget, and if you see the total sink that I discussed, what are the sources and what are the different sinks, it is almost 9.1, 9.1. And we fossil fuel 6.4, land change 1.1, tropical deforestation 1.6. Tropical deforestation has increased over the years. Similarly, the sinks of atmospheric increase in carbon dioxide 3.4, ocean is 2.0, and missing is 1.7. That is a challenging thing, but where the link is missing, where we are lacking, that we have to quantify. Similarly, we can say that the soil carbon depletion due to the historic soil erosion, because we have our seniors, they have quantified a data our in the Shivalik, Dr. Sanjay Arora, Dr. Vikas Sharma, and now recently in one of the project in DST, I have also quantified that up to 75 tons of soil is being lost per year per hectare in Shivalik. And if we get the average almost 30 years, and if we quantify the nutrients, we come with the conclusion that up to 300 to 400 kg of nutrients are being lost. And out of that, carbon is also being lost. And you can say that light to moderate or strong and extreme moderate, if you say that what are the carbon losses, depletion milligram per hectare is up to 40. That are quite challenging. So you cannot say that soil are being eroded by the wind or by water in hilly areas or in semi-arid conditions. Even carbon are being lost. Next, please. And this was given by Dr. Ratan Lal in 1919. What are the management aspects? Management aspects are very simple, that we should replace conventional summer fallow practices with chemical fallow practices with no tillage. So this is a quite confusing state, because earlier 20 years ago we all were emphasizing for going for tillage. Now we are saying that we should not go for we should not incorporate tillage into our operational practices in agronomy. But certain papers, very good papers, they are suggesting that tillage is responsible for disturbing the structure of the soil, which ultimately leads towards the loss of the carbon. So do we have to develop and diversify a sustainable animal cropping system to replace the current alternate year monoculture cropping system, which our honorable Prime Minister and honorable Agriculture Minister is also speaking, that we should, next year will be the international year of millets, and India was the capital of millets before the monoculture was adopted here. We have to go back towards certain diversified portfolios in agriculture. And there are certain adaptive and mitigative. Adaptive, you can say that we have to conversion to appropriate land use and option of sustainable options for managing the terrestrial and aquatic ecosystem under changed climatic constitute. Whereas the mitigation options, you can say that reducing the net emission either by capturing carbon dioxide from industrial plant. So you have to be very clear, the audience, especially the young one, that what are the sequestration measures. Measures will be two: adaptive and mitigative. You have to differentiate between two where you can play a part. Mitigative part, you cannot play a very big role except for using of, you can say, leaf color chart or certain gadgets. Whereas the adaptive part, you can play a very important role, because the mitigative part goes to the people where they are the policy makers, where they can take the decisions of injecting whatever carbon dioxide is coming, they can inject directly to the soil in the industry. And certain European countries, they are doing this. Next, please. So this is very important. This is black and white picture, but this is very important. This was given by Dr. Ratan Lal. There are policy consideration like the economic factor, environmental and health concerns, and ethical issues like generation, liquidity, landscape factors. And there are management strategies which are of importance to us, like land use farming system. Soil manager means we are the soil manager. What we can do? We can talk to the farmer to reduce the tillage operation. We could go for integrated nutrient management. We should go for the incorporation of the residues and plant animal waste, that how they can be incorporated into our daily practices in the field preparation. Certain policy issues which are not in our hand. Similarly, the site specific soil management option for sea sequestration is that we should go for conservation tillage, cover crop, mulch farming. They are having the potential that sequester carbon. The coming slides, the meta analysis of the data will be clearly indicating that they are having the capacity. Similarly, the soil fertility, if you use micronutrient, strengthening the nutrient cycling. Similarly, the water management, if you supplementary irrigation, surface and subsoil surface drainage, soil water management, water harvesting techniques, and the runoff controls like runoff management with terrace farming, waterways engineering, perimeter runoff control. You can say even simple measures like growing across the slope can have the potential to reduce the carbon loss from the hilly areas, from the area which is having more than 2% of the slope. Similarly, soil surface management and mulch farming. Use of plastic mulch. If plastic mulch is not available, you can go for the use of biological mulch. These are some of the tools which are being used at the direct happy seeder. Now the super seeder is coming, where we are directly sowing the wheat into the stubble, and it has also reduced the burning issue. Although the burning of paddy straw is a huge challenge in Punjab, but these are some of the tools which are having huge potential to sequester the carbon, because they are indirectly playing a very important role vis-a-vis minimum disturbance of the soil is concerned. Because once we are disturbing the subsoil upper layer, ultimately we are saying, this is the two picture, you can say tillage and no tillage. We should grow, we should use this zero drill, or you can say the happy seeder, where we can go and just drop the seed. And after, there is a problem, day before, 2 3 days back, there was one query from Dr. Vikas Sharma. He was acting as a co-chairman in session, that what is the only drawback the farmer is having with the happy seeder. He was saying that a window period of 20 to 25 days, when he is not seeing the crop being grown or coming out of the surface, इज ए चैलेंज, बिकॉज उसको फार्मर को लगता है कि क्रॉप मेरी ग्रो नहीं कर रही, वो 15-20 दिन में उसको लगता है कि उसका खेत तबाह हो गया. दैट इज ए चैलेंज. Now IRI has come up with some sort of mixture. They are saying that they are using it for this incorporation of this residue. They are having the potential. Next, please. Next, please. Next. Apusa decomposer. Yes, exactly, Indu. So this is very important. This is the John 6. This is a John 6, and he has came. This was also published in a very high-rated journal, Nature, and he came with an idea that process one and process two. If you clearly see this picture, and I have shared this PPT presentation with Dr. Sanjay Arora sir, and I will request him to share with the participant. If you clearly see that the once we are going for the tillage operation, you will see that the structural from T1 to T2 to T3, ultimately the carbon is coming out of that structure, which are ultimately encapsulated in the carbon, which is called as a particulate organic matter, particulate organic matter carbon, which is the most stable form of the carbon. And because of this, you can say, because of this using of tillage operation, the structure is opened and ultimately carbon is coming out of the structure. And this is the Torres Solon et al. 2017 Nature. He has came with this tomography picture, and you see the more carbon is being stored in the micro aggregate. This was also shared by Dr. Debashish Chakravarti. This is the slide which I have taken from him with his permission. That this is the major challenge, that how we can store the carbon. We are saying that carbon sequestration is possible, but the question is how much carbon sequestration can be achieved, and where we have to sequester the carbon, and more importantly, what are the different fraction of carbon which are stable over the years. He clearly depicted in his lecture that even if you are incorporating all sort of modules like integrated integrated nutrient management practices and other practices, he says that after 30 years there is a threshold, and if you stop for only 1 or 2 years, all the carbon which you have stored in the upper layer will go outside, and it will be once again gone dissolution to the atmosphere. This is a challenge, and he clearly depicted that from the meta analysis. He says that the only potential where we can sequester carbon is in the micro aggregate, the small portion of the soils we can store. And he said that there we can play where what is the role of the chemist. He said that we have to play with the chemistry of the carbon, where the role of the biochar and the nanoparticle and the stereochemistry can play a very important role. I again recall the experience of working with Dr. Sanjay Arora sir, Dr. PK Rai sir, and Dr. Vikas Sharma and Dr. AK Singh sir, where we have an international conference, and one of the friend of Dr. Sanjay Arora, he came from Australia, he was a student of Dr. Bijay Singh. He shows us clearly that playing with, you can, there's a structural component of the carbon. We can store carbon for 300 years normally, which is being stored for 30 years, because just with one modification of this biochar and these nanoparticles. And if you see the global data analysis, this was the paper by Mandal et al. You will clearly say that the bulk density, there is no change, slightly almost same, but the mean void diameter as well as the field capacity and the root density, they all have increased with the conservation agriculture, with the practices which I am postulating to you from the last half an hour, like resource conservation technology, incorporation of the leguminous crops, use of the cover crop. These all plays a very important role, and this is the data which was he has taken from the across the globe from 300 studies. Thank you. Next. Next. And studies from IRI and other institutes like Kumari, Das, and Mandal et al., they conclude preferential accumulation of carbon in macro aggregate plus soil structural improvement. That is greater micro aggregation. This was also reported by Devashish in 2022. But small fraction comprises greater. Small fraction comprises almost 32% of the, you can say, this sequestration of carbon. Agriculture production management to enhance carbon, we should go for no tillage or reduce tillage, increase crop rotation, conservation measures, using high residue crops such as corn, grain, sorghum, and wheat, inclusion of millets, and using cover crop. This was the experiment which we have conducted in our one of the MSc studies to the use of cover crop. It had played a very, positive role vis-a-vis various properties of concern like the sediment yield even, and selecting of varieties and hybrids that store more carbon. Next, please. Only 5-6 slides are there. These are few of the gadgets which I want to show you, that because C and N, we cannot work with carbon in isolation, because carbon and nitrogen, they are having a, important relationship, that CN ratio is. So few of the gadgets which are of great importance vis-a-vis climate change is concerned, vis-a-vis sequestration is concerned, is the use of leaf color chart, which we are propagating in our area, and use of chlorophyll meter, little bit expensive for the experimental point of view. Experiment, you can use it for sensor. And we came with a conclusion, Dr. Arora sir, that 28 to 30 kg of urea is being saved in coarse variety, and 5 to 6 to 7 kg, 6 to 8 kg of urea in basmati, without any harm to yield. And even you can say that this urea otherwise would have gone to different fates like volatilization, ammonification, leaching losses, which ultimately leads to the greenhouse gases, which we have discussed in our first part of our lecture. That these are the smart gadget, you can say, and it costs almost 100 rupees, and it is a prototype of the ERI. We have not played with anything. We are just trying to popularize it. Next, please. I think these are the crop diversification pictures. I know. Next, please. Yeah, this is very important technology, water saving technology, the laser leveler. It has, I will say that it had revolutionized the Indo-Gangetic plain. That with the use of these water saving technologies, that the farmers they are able to save almost 3 lakh liter of water by 1 centimeter modification of laser leveler. And there was hue and cry when it was started, but I will say with the firm recommendation, now the farmer of Katua, Samba and Jammu plain, they are also using laser levelers, sir. And water, you can say water productivity had increased. Although this is not my part, the agriculture engineering Dr. Srivastav, he will be sharing with you certain part. And this one, if there are certain you can say tensiometer developed by Dr. Kukal, and there is a one simple method. You insert the pipe into the, this I have taken from PAU field, irrigate when water is 15 centimeter below the surface. These are very, very easy tools which can be used for the water, because we are talking in terms of climate change and carbon sequestration, but these are the real terms, real terminologies, real modules which we have to work as a soil scientist in the field. Next please. Sir, this is the conservation agriculture is much more than zero tillage. There is a lot of confusion going on, and this was the concept which I have taken with the help of Dr. ML Jat, and he said that we cannot say that this only zero tillage is conservation agriculture. Conservation agriculture comprises of much more than zero tillage. We have to adopt certain modules, that the crop residue management, incorporation of crop residue management, appropriate pest and disease management, appropriate seeders. What we, if the soils are heavy, what type of seed, what type of instrument you are using. If your soil is light, what type of instrument you are using. Similarly, the water element crop management component. We can say that conservation agriculture is having the potential to do much more carbon sequestration compared to the conventional methods. Next please. If you see, this is the picture I have taken from one of the book, that this is the farming system carbon potential. That if you see that after recapitalization, you will see that 136 tons of carbon per hectare is being captured in soil, where we are using certain modules like grass contours, strips, boundarying the tree planting. I can say IFS model, you can say this is just like an integrated farming system model. If we compare it with the model which is having no such interventions, clearly there is almost, you can say, 40 to 46 tons of carbon is being stored more in this. And this I have taken from Dr. Ratan Lal sir book, Agro Ecosystem and Carbon Management. Next please. Sir, I will be running this because I have already discussed this, the resource conservation technologies, no tillage, laser land leveling, direct seeding of rice, leaf color chart and crop diversification. No tillage is a win-win technology because it saves water, it helps early sowing, improves soil organic carbon, and ultimately sequester the more carbon, increases the fertilizer use efficiency, it reduces the soil erosion, which Dr. Sanjay Arora and his team, they have quantified that almost 75 tons, and on an average 30 to 35 tons of soil is being lost in shivaliks. These are few of the technologies which should become the buzz for the Krishi Vigyan Kendras, and they should come up with a clear roadmap, that they should go to the farmer and say that even growing across the slope, and even if you are making a bund, you will reduce the carbon loss as well as the nutrient loss, because once the sediments are being lost, it is not the sediment, along with the sediments nutrients are also being lost. Next please. So next please, this is the climate smart village concept which I have already described, so I will be missing this. So question is now one very important, and this will be little bit of interest to the farming community, and we all of us, Dr. Sanjay Arora sir and Dr. PK Rai sir and Dr. Vikas Sharma sir, that we are talking about the economic, we are talking about the carbon sequestration, but what is the economic return the farmer is getting? So this we have quantified, these people have quantified, and they have came with a conclusion that we can say that we if we remunerate the farmer with certain economic value, then he will go for sequestration. Otherwise, why farmer will go for sequestration? And as per the Kyoto Protocol, as per the new Paris Agreement and the Glasgow Conference, there is a certain formula which are now being, which will be implemented very shortly in India also, that if a farmer is going for carbon sequestration, he should be compensated at the rate of $10, 1 ton of $10, 10 for 1 ton of carbon for 1 hectare of soil. That is basically an encouraging, you can say, remuneration to the farmer, so that the other farmers can also sequester the carbon. Next, please. Next, sir. So I will be missing this because there is a one formula which I have already shared, RF minus RC. This is the delta of C for 0.4 tons of per hectare per year. And if you, this is, the example was taken by from the Montana, changing from a crop fallow rotation to a continuous, given average value of this. Next, if you calculate this into the equation. Next, please. Next. सर आपको मैंने ऐसी तकलीफ में डाल दिया. ये है सर, the cost of producing a tons of carbon, that is farm operation cost plus contract cost, that is RF minus RC divided by delta C plus contract cost. It almost comes with the $25 per ton of produce which you are getting. So you can say that the farmer, if you are giving them almost 2,500 in terms of dollar, you can say 2,000 of rupees to the farmer, definitely they will come and they will sequester carbon. Otherwise the scientists will come and publish their paper, they will come to the lecture, they will come to the different platform, and they will say that go and sequester the carbon by forming, by adopting these modules. They will not do, because farmer is ultimately more concerned about the profitability as well as the productivity of his farm vis-a-vis compared to the carbon sequestration. Unfortunately, this is the lacking area on part of us also. Now we are making awareness through different organizations like Academy of Natural Resource Management or NAS or Academy. They are organizing certain, you can say, seminars and symposium where even students are now being aware. And to part of this, we can say that agriculture producers should be paid as per the carbon sequestration. I have discussed with the Kyoto Agreement as well as from the Chicago Climate Exchange. You will be very you will be surprised to know most of the youngster scientists that New York Stock Exchange is having one quantifiable, you can say, क्या बोलते हैं उसको, entity in terms of carbon sequestration. That should also happen to every country, especially the potential like China and India is having, where we can sequester carbon, where the carbon is being lost every year without any, you can say, interventions. So sir, with this I have reached to almost my last slides. I will say last slide, sir. So we can say that with increased focus on climate change and the development of the Kyoto Protocol, Paris Agreement, other international treaties which may emerge soil conservation through carbon sequestration, reduce the net carbon dioxide emission by systematically removing carbon dioxide from the atmosphere. It is very easy to say that you should go for sequestration of the carbon, but I told you that sequestration of the carbon is a very huge task, because I have learned from my seniors like Dr. Vikas and Dr. Kukkal and Dr. Sanjay Arora, that even if you are going for 30 years of regular integrated nutrient management practices and you miss 1 year, there is one paper by Khan et al. In Soil and Tiller Research that ultimately the dip of carbon will be the same. So it is a continuous proper process. You can say it is like yoga or exercise which a person should do regularly. It cannot be that I will do yoga in once in a 365 days and I will be having a healthy heart, or my eyes will be okay, or my body will be okay. So carbon sequestration, sequestering the carbon in the agriculture system is a regular process. And the most important component from this lecture, you can say, is that which form of carbon. I have not delved into that because that would have created more confusion, like labile carbon, non-labile carbon, and recalcitrate carbon. But this is very clear that the form of carbon is very important, and more importantly, where you are storing it. Upper 15 centimeter, and that too with the micro aggregate or macro aggregate. So we are having a choice. We will wait until the catastrophe fails us, or we can act to fail the catastrophe, as the father of nation is saying. And I am highly thankful to Dr. Sanjay Arora sir. He has been a source of inspiration for all of us. To Dr. Atul C, Dr. PK Rai, Dr. Vikas, and all the important members of the society like Dr. Anchuman Kohli, Dr. Bhardwaj. They are always treating me like a younger brother, and they gave me this opportunity to interact with you. Once again, a huge compliment to the academy that within a very short stipulated time they had organized such a huge, footprint across the globe, where scientists, I can talk from Dr. Ratan Lal to Dr. Mohapatra to Dr. Pathak to Dr. Day. They are coming to our academy, and being a life member of this academy, I feel privileged, sir. Thank you once again. Thank you very much. And if there is any query, I am able to reply to you. Thank you very much, sir.
Thank you, Dr. Arya. And you have discussed in detail about the carbon sequestration and soil health management and what is the importance of carbon. So now it is open for discussion, and request the participant, if have anybody any query or doubt, you may ask. Just unmute themselves and ask the question, or put their question in the chat box.
First, I will be complimenting Dr. Arya for giving a comprehensive talk on carbon sequestration. I have one query from Dr. Arya, because
Yes,
he is interacting with large number of scientists across the world. How much carbon can be stored in the soil? For example, if we are adopting organic farming, natural farming, or residue incorporation,
yes,
maximum
sir.
quantity of organic carbon up to the what level can be retained in the soil?
Sir,
Because
yes, sir. Sir,
mm,
this is the global stock is almost like you can say as per 2010 is 3012 pg per soil. That is petagram per carbon. And historically, we can store up to, there is a limit of 133. So net deficit is almost, you can say, 31%. Still there is a net deficit. And I will be
actually,
share.
this
Ji,
is the
ji.
this is the total carbon content. But if we are concerned about agriculture, especially
Yes,
the
sir.
organic carbon content up to maximum threshold level. Say, for example, in India, the average is below
Yes,
0.5%
sir.
in almost all the soils.
Yes, sir.
Uh, so, what will be the means if we change the farming,
Yes,
say
sir.
to the totally organic, to totally residue management, we follow all the things.
Yes,
Up to
sir.
what level we can get the soil can sustain organic carbon? क्या
Sir,
ऑर्गेनिक कार्बन का लेवल 4% हो जाएगा हमारी एग्रीकल्चर सॉइल्स में? पॉसिबल है?
sir, sir, that is what I have learned, that this carbon sequestration is an enigma. But there are certain big papers which are saying that up to 8 to 22 pg per soil can be captured for a 20-year stability of carbon in soil by adopting certain modules, by certain integrated nutrient management, using of cover crop, residue incorporation. But even after that, the question once again will come that where we are storing and what form of carbon is there, whether it is a labile form, whether it's a non-labile form, whether it's a recalcitrate form. And soil organic carbon loss, you can say that we can say that the potential is there. There is one report by that centerman. He says that we are having the potential of 133 pg of carbon if we go for incorporation, but still there will be a deficit, because ultimately the sink is less vis-a-vis loss, because evolution, you can say the evolution, or you can say the developmental path is emitting more carbon. Even the soil can sequester carbon, there will be a net, you can say, deficit in that. I will say that the 20 to 33 pg c per year can be stored. Maybe I am wrong, sir, but this is what I have learned.
Okay, thank you. Any query from participant?
Excuse me, sir. Am I audible, sir?
Yes, yes.
So this is Khayali Vedya from Bhuj. Sir, my question to Dr. Vivek sir is, sir, as you have explained very well about all the aspects of carbon sequestration. Sir, my question is there any particular method that we can assess labile organic carbon from the soil? The amount of the total labile organic carbon.
If you want to go for you can say the best method, you can say the which was given by oxidizable carbon. It will give you an exact idea about that. But since people have quantified it in chemical analysis, that still 30% of the loss which is coming through the reaction is not being captured in that particular method. So you can say that the oxidizable method is the best method vis-a-vis the lab condition is concerned. But now people are coming with these CHNS instruments and ICAP models. They are using high-end instruments. We can go on that.
But sir, I still have query that CHNS is able to measure the total carbon which is present in the soil.
Yes,
Oxidizable carbon is the method which we use is Volkley and black titration.
Walkley and Black.
That gives you the total organic carbon. And my understanding tells that labile organic carbon is even the even the it is a part of the total organic carbon which is present in the soil. So my question is that how we can separately measure the labile organic carbon in the soil? Is there any particular SOP from which we can assess the labile organic carbon in the soil?
There is one method given by Dr. Zua and al., and I will be sharing with you that how you can go for this estimation of soil labile organic carbon and potential turnover. And this is an incubation procedure, and the method was given by Jenkinson and Paulson, fumigation incubation. But
Okay,
this is not popularized because it is having some cost effects. So you can say that we are little bit helpless in this. If you want to go for exact estimation of the labile carbon, but still we have what the in Indian aspect we are using the same method, and oxidizable carbon estimation method is the best method as far as my knowledge is concerned, because labile carbon is a
Actually,
fraction. Gee,
I can add the method of Blair and whatever you told by Johnson is being adopted in India also. But actually, it is a based on the same aspect. Means it is a oxidized form. We are
yes sir,
using KMNO4 as an oxidant in that. Uh, but problem is that the method was is somewhat tedious in laboratory. We are
yes sir.
getting uh, we have also done that for some of the samples, and it takes time, but the
Jenkinson,
accuracy
yes sir,
accuracy
also.
also varies, because all our characterization of the soils or ratings for organic carbon or availability as per the crop needs, if we have defined the relationship, it is all based on the organic carbon, Berkeley and Black. And whenever you means analyze labile form of that carbon from the soil by using Blair and Johnson method, we do not have the reference for that to correlate our data in terms of means crop growth or yield or soil stability. That is the problem. But you can if you are working in your laboratory for just for the assessment of soil and soil carbon pools, then you can very well adopt this approach. And many of the students, not
Yes sir.
only from
Sir,
IRI,
even
PAU,
yes sir.
as well as
Yes
in
sir.
Jammu also, have analyzed labile carbon pool
Sir, even
in
my
their soil.
student, yes sir.
Yes,
Sir,
to
even
get
my student, one my MSc student, now she's in USA, Dr. Japneet Kukal. She has gone for this labile carbon estimation carbon pool, and she has used the method gone given by Paulson and even by Skimstart et al. 2006. But the only problem is that, sir, what we have learned, that we are now more concerned about the values which are being adopted at the international level, and it should be uniform in nature, which you have described very in very detail, that this normal method is being utilized by almost all the countries, and we are being giving the threshold value that 0.4 4 to 7, and then more than 7.75 can be utilized, because now methods are coming and they are giving you an exact white value. And the for particulate organic carbon, you can say again the oxidative agent is against the potassium permanganate oxidize. Only the capturing is a issue, that these new
actually
methods.
uh, for academic interest and for the
Yes
interest
sir.
of the knowledge,
Yes sir.
we have to analyze different active and passive carbon pools. We have with us Dr. Mishra, A.K.
Yes
Mishra,
sir.
who has worked on these aspects also. If he is available,
Dexter,
he
thank you.
can
Thank
he
you
can
so
put
much.
he can put
Yes
more
sir.
light on that.
Yes
From
sir.
Yeah.
Erie, he is from Erie. Hmm.
Okay.
Thank you, Dexter, for giving this opportunity. I think Vedya is very valid. And uh, basically, what happens is the project that we get is very short-term projects. For example, 3 years or 5 years of project. But understanding the carbon dynamics, it's very important to have long-term experiments. So sometimes what happens, the mineralization is as good as what we sequester in the soil. So it is somewhat nullified effect. what we can do is, for short-term changes, we can have some indicators that we can choose. I think these days, people, if you search in the from 2015 to 2022, you will find several papers on dissolved organic carbon. So basically, what they use is they just seek these soil samples with concentration of water only for 16 hours, and then they just supernet and like they remove it and then take the liquid and then they use it aliquot and then analyze that. Furthermore, if you have like hot water extractable carbon, so with cold water they extract. Some they do it for example the fungi. So fungi, hyphae, and those aspects can also provide some you can say chemicals that can bind. For example, glomalin content. So if you see recently people are talking about glomalin. So it helps in binding of the soil particles together and making aggregates. So it's also a source of carbon, being it is derived from the fungi. So several methods are there. Of course, for example, in India, the problem is standardization of the protocol. I think uh, Sanjay sir is doing wonderful work in defining and doing for Indian scenarios. So if you quote like his paper, he is having several papers on these labile carbon pools. You can quote on that. The other is ignition. So if you have muffle furnace is available in your laboratory, what you can do at different temperatures, as you know, like if it is 1200 and above, then whatever the carbon is available, it's all into the calcium carbonate form. So TIC, inorganic carbon. So below it 800, if you have the temperature of 800, it is having the the passive pool of organic carbon. If it is 400, then it is active pool of organic carbon. So there are several methods that we can explore and we can use it. Thank you, Daxab. Thank you for offering this opportunity.
Thank you for your input, Dr. Mishra. It depends upon the means the project you are working on, but
Absolutely.
in general sense, there are many pools that represent the activeness of the carbon in the soil. Water soluble, dissolved, hot water. So you can adopt this, but that if we are talking about agriculture as a whole, we are more dependent on the uh, organic carbon determined by the Vauquelin Black, because all our estimations are represented and ratings as well as crop simulation has been done using these models,
Sir,
these
one more
methods.
query, sir. I can ask to Dr. Mishra, sir, if you permit me.
Yes, yes.
Sir, I want to ask you, sir. There is a lot of confusion because I came with this MSc work and the POC, sir, the particulate organic carbon.
Mhm.
It has given us a rough picture, but we were not having this X-ray diffraction, or you can say the tomography. We just got a rough idea given by this Cambrella and Elliott in 1992 that, and even the modified Hashing method. And now when I have sent this paper to one publication unit, and they are now saying that if you are having that sample, you can get it analyzed for these diffractions or some tomography. Sir,
Hmm.
can you shed some light at why they are saying, and why it is becoming so important, especially the POK?
Hmm.
That yes, sir.
So I think see what is happening these
POK,
days is
POM.
POM, sorry,
particulate organic matter.
the carbon I am talking.
Or carbon, you can say. So,
Yes.
what is happening these days is people are more interested in understanding the alkyl group, or you can say in simple terms like whether the carbon is having aromatic or in a ring form or in aliphatic like a chain form. So if we know that, we can have like persistency. We can increase the persistency of the carbon for how many years it is going to retain into the soil, and based on that, we can make it our decisions. Like, okay, we need to do this kind of practice for these years, or even not applying the residues for 5 years in conservation agriculture. If you have in the past 5 years, so
Hmm.
5 years applying residue and then leaving 5 years for without residue, and again
Yes.
adopting these. So these are the methods that like FTIR, people are interested these days on understanding the bondings of the carbon. So that's one. The other one, basically, once we talk about POC, people are interested in understanding whether the microbes, the soil, so whether the microbes can penetrate into the soil or not. So if the aggregation is strong, so particulate organic carbon is somewhat a good indicator for those soils. So therefore, they want to understand like which carbon is holding that, whether it is aliphatic, that means not so stable. So it is somewhat active pool. So if it is aromatic, then it can stay for longer. And then their ratio, people are interested in their ratios also. So I think this is how these days the reviewers are
Okay,
commenting.
okay. Thank you,
Thank
sir.
you very
Thank
much,
you.
sir. Thank you very much, sir.
Thank you. Any query from participant? Any other query?
Yes, sir. I have one question.
Yeah. Please introduce yourself.
Sir, I am Prashant Rathod from Dr. PDK Vyakola, Maharashtra, sir.
Mm-hmm.
Sir, I have one query regarding what is difference between sir soil quality and soil health. Is it synonymous or sir different somewhat?
So I think they are. One of the slide was clearly depicting that they are used interchangeably, but the soil quality is a term which should be preferably used by soil scientists, but it comprises of many soil indicators like biological, physical, and chemical. Whereas the soil health is also a very good term, but it is being used mostly by farmers in terms of, you can say, descriptive part. My soils is good, having a good, you can say, aggregation, color is good, there is no water logging, but they can be used interchangeably. But now people are concentrating more on soil quality because it comprises of some qualitative and quantitative both. Qualitative part is soil physical, chemical, biological, and quantitative is the produce which is being coming out of that particular soil. Thank you.
Okay, thank you, sir. But sir, what should be my answer, sir? Somebody is asking me. It's different, synonymous or sir different?
They should be used interchangeably, but scientist, if he is a scientist, if he is an agriculture technocrat, he should use the word soil quality.
And farmer using soil health. Okay, sir.
Yeah.
But
But
sir, again.
All the things, whenever you are in this training program, we are discussing mainly the science, but actually the science of the health is the quality. So if we are discussing the soil quality with a larger fraternity from different fields, then it will be better to use soil health. आपको किसानों को समझाना है, आपको किसी स्टेज पे बात करनी है, तो सॉइल हेल्थ ज़्यादा इजीली अडॉप्ट हो जाता है. सॉइल क्वालिटी में बहुत ज़्यादा चीज़ें क्वालिटी, जैसे डॉक्टर विवेक ने बताया, क्वालिटेटिव एस्पेक्ट पे बात करते हैं. तो क्वालिटेटिव एस्पेक्ट्स पे जब बात और इन डेप्थ उसकी इंफॉर्मेशन चाहिए. सॉइल हेल्थ में आपको बेसिक इंफॉर्मेशन से, तभी सॉइल हेल्थ कार्ड के कंपोनेंट्स आपने देखे होंगे.
Yes, sir.
उसमें पीएच, ईसी, ऑर्गेनिक कार्बन और एनपीके और जिंक कॉपर आयरन मैंगनीज ही है ना. उसमें टेक्सचर का बहुत ज्यादा जिक्र है, ना बल्क डेंसिटी का, ना उसमें ईएसपी का, ना. तो इसलिए कि जब हम सॉइल क्वालिटी में जाते हैं तो हमको पूरी उसकी बायोलॉजिकल हेल्थ भी देखनी है और फिजिकल हेल्थ भी देखनी है और केमिकल हेल्थ भी देखनी है. जब तीनों हेल्थ को देखेंगे तो वो क्वालिटी को डिफाइन करेगी.
So, okay, sir.
तो
Thank you, sir. I get it, sir.
इसीलिए ओवरव्यू के लिए ठीक है वो.
Sir, again, I have small question, sir.
हाँ पूछिए.
Sir, if we are adding suppose FIM and then at the same time accumulation of crop residue, sir, enrichment of, sir, if adding FIM, enrichment of which form, sir, among the rebel faction, sir?
फिर से बोलिए, क्या कहना चाह रहे हैं?
सर, अपन ने समझो FIM ऐड कर दिया तो कौन सा फॉर्म में इनरिचमेंट होगा, और ग्रीन मैन्योर क्रॉप ऐड करेंगे तो कौन सा फॉर्म इनरिच होगा? सपोज दोनों कंपैरिजन वेरी लेवल.
ये दोनों कोई कार्बन तो आपने ऐड नहीं किया ना, ये दोनों तो ऑर्गेनिक मैटर है.
yes, sir.
ये जब ऑर्गेनिक मैटर डिकम्पोज होगा विद द एक्शन ऑफ माइक्रोब्स इन प्रेजेंस ऑफ फेवरेबल टेम्परेचर, मॉइस्चर, उसके बाद जो ट्रांसफॉर्मेशन होगा उसमें कार्बन, ह्यूमस, ह्यूमिक एसिड, ये सब फॉर्मेशन होगा. ये जब फॉर्मेशन होने के बाद सॉइल के पार्टिकल्स के साथ और आपकी मैनेजमेंट प्रैक्टिसेस के साथ ये एक्टिव और पैसिव पूल्स में जाएगा।
यस सर।
ठीक है, तब उसके बाद आपको ये पता चलेगा कि कौन सा एक्टिव बना या कौन सा पैसिव बना। बट व्हाट यू आर एडिंग द ऑर्गेनिक मैटर विच इज अ सोर्स ऑफ कार्बन।
ओके सर, ओके, थैंक यू सर।
थैंक यू। एनी अदर क्वेरी? कोई और पूछना चाहता है? देवव्रता पूछ लो। Devrata is writing in chat box. I asked him to directly communicate with the speaker. We will share the contacts of the speakers. If you have any query later on also, you can discuss with our eminent speakers from different fields, different working areas. So that can be useful for your future research and academics. So, Dr. Rai, please continue with the.
Yeah, thank you. Thank you, Dr. Arora. Now we are proceeding towards next lecture. That will be delivered by Dr. Jagannath Pathak. He is the professor and head Department of Soil Science, Banda University of Agriculture and Technology. And Dr. Pathak did his master and PhD from Kanpur, and he has having more than 20 years experience in the field of soil science. He was also associated with the ACRIP MSP in Lucknow University. He has more than 50 research papers in his credit and 2 books, and he has guided more than 15 students for MSc and PhD. And he also is associated with the extension works, and he worked in KBK also. So he has visited many nearby countries as a visiting scientist. So now I request Dr. Pathak to deliver his talk on the soil health deterioration and their management.
Thank you, Dr. Rai. Very first, respected Dr. A.K. Singhi, Chairman, President of ANRCM and Chairman of this training program. Respected Dr. Sanjay Arora, sir, Secretary ANRCM and Convener of this National Training Program. Respected Dr. P.K. Rai, Course Director of this National Training Program, and Dr. B.M. Arya, Course Coordinator of this National Training Program. The National Training Program is designed on a very important topic on soil health management, which is very globally it is important topic. Now my topic is associated, or you may say linked with this. I am sharing the slides, sir. Excuse me. My topic is also related with this training program, that is the soil health. Soil health deterioration and their management. Because without healthy soil, we cannot produce the optimum quantity of food, feed, and fibers. And we consider 3 mothers of human being. One is the mother that gave birth on this planet. Another mother is Gaya Mata, Gau Mata, and as per my view, another mother is the Dharti Mata, Prithvi Mata. So I can say कि माता भूमि पुत्रो अहम पृथिव्या, माँ भूमि एक माँ है और हम सभी उसी भूमि के पुत्र हैं. और इसीलिए हमने हमेशा देखा है और हमारे संस्कृति में है, चलन में है कि जब हम सुबह उठ करके अपने रोजमर्रा की जिंदगी को शुरू करना चाहते हैं तो सबसे पहले पृथ्वी को यानी धरती माता को प्रणाम करते हैं और कहते हैं कि समुद्र वशने देवी पर्वत स्तन मंडिते विष्णु पत्नी नमस्तुभ्याम क्षमस्व, यानी हे माँ पृथ्वी, मैं अपने दैनिक जीवन को चलाने के लिए आपके ऊपर पैर रख रहा हूँ, अपने भरण पोषण के लिए निकल रहा हूँ, आप मुझे क्षमा करें। इन सच ए वे soil health is important for all of us. So my topic is soil health deterioration and their management. I have designed my topic on different aspects. That is the very first. If we are discussing about the soil health deterioration and their management, the very first question is arising in my mind. That is what is soil health? Now, followed by what are the principles that can govern the soil health? If any soil is healthy, then what are the characteristics, or you can say how we can identify the soil, good soil health or bad soil health. There are some characteristics that a good soil should possess. Now, why we care about the soil health? Now, what are the reasons?
पाठक
जी
स्लाइड
जी
मूव
सर,
नहीं कर रही,
अभी मूव नहीं की। अच्छा, ओके सर,
फर्स्ट स्लाइड पे ही है।
यस सर, थैंक यू सर फॉर गिविंग मी इंडिकेशन। Now, then followed by what are the factors that can affect the soil health? There are several factors that can affect the soil health. What are the consequences of the soil health deterioration? That is the fatal effect of soil deterioration. If the soil health is deteriorated, then how we can solve these problems, or we can say how we can convert the unhealthy soil into a healthy soil. So the surprising solution of soil deterioration. What are the major driving forces for soil health management? And how do we measure the soil health and how do we manage the soil health? What are the strategic framework for effective steps for improving soil health, productivity and sustainability? Now and at last, there will be conclusion. Now, what is the soil health? Just like a healthy man, जो स्वस्थ व्यक्ति होता है उसकी पहचान क्या होती है? उसके अंदर एक ऊर्जा होती है और काम करने की इच्छा होती है. Similarly, a healthy soil is defined as the continued capacity of soil to function as a vital living ecosystem that sustains plants, animals, and humans. Healthy soil gives us clean air and water, bountiful crops and forests, productive grazing lands, diverse wildlife, and beautiful landscape. These are if any healthy soil possesses these characters, then we can consider or we can say that soil is a healthy soil. Healthy soil must have such type of characteristics. What are the principles that can govern the soil health? There are 4 principles by which that can govern the soil health. First one is the minimize disturbance. To minimize the disturbance means reduce the tillage operations and other cultural practices and maximize the biodiversity. Biodiversity is the major aspects of healthy soil. If anywhere is the plentiful of biodiversity, then the soil must be healthy there. Maximize soil cover. Soil always should be covered with some crop residues and other, or you can say grow the crop on that soil. Covering of the soil will help in the maintaining the soil health. Another principle is the maximize living roots. On the basis of these 4 principles, we can maintain the soil health. which is essential for the human being, because healthy soil can produce sufficient amount of feed, fiber, and food to the human being, animals. Now the characteristics of good soil health. Which soil we can consider this is the good healthy soil? Those soils are healthy should possess following characteristics. These characteristics, like if soil is healthy, then that soil have good soil tilth, and that soil also have sufficient depth. Depth means that sufficient depth can help in growing the crops, because if the soil depth is not sufficient, then the root cannot penetrate in the hard pan, and ultimately the crop growth will affect. So any healthy soil should have sufficient depth. Now the healthy soil should also have good water holding capacity, because water is essential for all the crops. If the soil has not water holding capacity, then several problems will arise, and cost of cultivation will also increase due to the increasing of number of irrigations. And healthy soil should also have good drainage. Those soils are healthy, that soils should have sufficient supply of essential plant nutrients that's required for a crop plant. Because without sufficient supply of essential plant nutrients, or you can say nutrient to the crop cannot be grow properly. So a healthy soil should have sufficient supply of essential plant nutrient, sufficient but not in toxic amount. Because if the nutrient is toxic, then that harm the crop. And if the nutrient is deficient, then also reduce the growth and yield. So the optimum supply of nutrient, or you can say sufficient supply of nutrient, is the essential. And such type of condition we can got only in healthy soils. Those soils are healthy, that soils always have very good population of beneficial microbes. Because if the microbes are not in sufficient amount in any soil, soil cannot be healthy, or you can say cannot be fertile. Microbes are one of the major aspect, or one of the major component of a healthy soil. Without microbes, we cannot provide the applied DAP to the plants. Until or unless applied fertilizer cannot be consumed by the microbes, not to be applied and not to available to the plants. So healthy soil should have very good, or you can say plenty of microbes benefits. Those soils are healthy, that soils should have low weed pressure as well as low levels of soil-borne pathogens. We know that several diseases are soil-borne diseases, and several nematodes and others harmful pathogens can also born from the soil. So the good soil have very low level of soil-borne pathogen, and a good soil health always have productivity potential. Now the question that why we should care about the soil health. As I say earlier, without healthy soil, we cannot got the sufficient amount of food, feed, and fibers. So we should care about the soil health. Soil is one of the natural resources that supports human civilization. Without a productive and healthy soil, the prospect of producing enough food to feed and even increasing human population is impossible. जिस गति से जनसंख्या बढ़ रही है, उस गति से बढ़ती जनसंख्या के लिए healthy soil is important for the producing of sufficient amount of food and feed and fiber. We have many degraded soils across the globe that are no longer productive and can only be regenerated to a fruitful state by applying soil health principles. That principle I have discussed earlier in my slide. The global trends show that 20% of cropland, 16% of forest land, 19% of grassland, and 27% of rangelands are in persistent decline in productivity due to soil degradation. This is the what scenario, how our productive soils are converting into barren land, or you can say in unproductive land. This is the scenario. So this can have sufficient effects on global food security if not addressed. If we not consider these the problem, then we will face the several challenges. Therefore, it is essential to care the soil health like human health, like my children's health, like my family members' health. Always consider these are the some soil health deteriorations like nutrient deficiency. Several nutrient deficiency can arise in the unhealthy soils. And deforestation can also affect the soil health. Soil erosion is a major issue that can affect the soil health. Pesticide use can also affect the soil health. Loss of biodiversity can affect the soil health. Problem soils and soil pollution. Similarly, flood and soil loss, less use of organic manure or compost, burning of crop residues, irrigation with polluted water. These are the factors that can affect the soil health. Here I summarize these factors in a table form. What are the causes of soil health deterioration? I have divided the several factors into two groups. That is the major causes of soil health deterioration and other causes of soil health deterioration. If we see the major causes of soil health deterioration, then very first is the intensive farming. Intensive farming can also affect the soil health because we are continue cropping without giving the rest to the soil. बगैर आराम दिए हम लगातार खेती कर रहे हैं, इससे भी हमारी soil health प्रभावित होती है. If we are growing or you can say practicing intensive farming, then nutrient mining will be occurred. Another reason for the soil health deterioration is the imbalanced fertilizer use. Imbalancing in the fertilizer application is a major problem for the soil health deterioration. Here, my opinion is that imbalancing in the fertilizer use at the farmers level, it is only due to the lack of education among the farmers. Farmers not know how much nitrogen apply and how much for that nitrogen, how much urea. Farmer cannot differentiate, most of the farmers cannot differentiate how much apply the nitrogen, it is urea or nitrogen content. So imbalancing it takes. Another reason is that government has not manufactured or not promulgated the policy to manufacture the balanced fertilizer like NPK. From last few years, government have manufactured by the different manufacturing fertilizer companies like NPK 10:32:16, ORR 10:10:26. Such type of balanced fertilizer, if manufactured very earlier, then the farmers should apply. Then farmers will apply that balanced fertilizer. Then the imbalancing will not occur in the farming, in the agricultural practices. Another reason is the indiscriminate use of herbicides and pesticides. It is also a very serious problem causing the soil health deterioration because we are cultivating the crops for the more and more profit at any cost. So, and another reason is that private concerned companies are also selling more and more insecticide and pesticide for income generation. There is no concern what will affect the soil health. So there are indiscriminate use of herbicide and pesticide can also affect the soil health in a very huge amount. Among all the chemicals like fungicide, pesticides, and growth hormones, herbicides are more injurious for the soil health in comparison to other. Another is the contaminated surface water into soil. Industrial polluted water is going into the soil and ultimately deteriorating the soil health. Deforestation is the major concern that can affect the soil health because forestation is providing a cover to the soil, and ultimately forest area you can find the more organic matter in forest area soils. So deforestation is a very serious issue which is affecting the soil health in very bad manner. Soil pollution is another reason that can affect the soil health. Soil erosion and loss of soil biodiversity. Soil erosion. There are several types of soil eroded by the water and wind. In case of water erosion, splash, sheet, and several types of erosion, always muddy soils flowing, or you can say runoff from my field, that is the fertile soil, because the upper layer is removed by water erosion, that is the fertile soil. Ultimately, soil become unfertile, or you can say health of the soil is deteriorating. Depletion in organic carbon content and faulty tillage operation, it is also a reason. Other causes are acid rain, poor quality irrigation water, improper landfill, and illegal dumping. Genetically modified crops. Genetically modified crop means in India, only one genetically modified crop is under cultivation, that is the cotton. If anybody continuously growing a cotton crop on a particular field, then he can got the barren land after some time, because wheaty cotton is a very fertilizer loving or nutrient loving crop and removing too much nutrient from the soil. Exhaustive crop, you can say cotton is a exhaustive crop that remove huge amount of nutrient from the soil. Another reason is the burning of crop residues. All are know about this. All are very learned persons are connected with the training. So burning of crop residues is also another reason that can affect the soil health. Improper discharge of nuclear wastage. These are the consequence of industrial development. Such type of material is adding in my soil and ultimately affecting the soil health. Or you can say this is the result of more and more development at any cost. So ultimately such type of discharges or byproducts are adding in the soil and ultimately affecting the soil health. Acidification and salinization are also factors that can affect the soil health. What are the fatal effects of soil health on soil health deterioration? If the soil is continuously degrading, or you can say if the soil health is continuously deteriorating, then what happens? Then the land degraded, declining in nutrient efficiency. Nutrient efficiency, as we know that the nutrient use efficiency is day by day decreasing, and cost of cultivation is increasing. Loss of arable land. If we not manage the soil health, then our cultivable land, or you can say arable land, will convert into barren land or fallow land. Pollution and clogging waterways, loss of fertility and declining in productivity. Fertility and productivity will also affect due to the soil health deterioration. It means the capacity of soil to supply the nutrient and capacity of soil to produce the crop will reduce. So how we can solve these deterioration, soil health deterioration problem? How we can manage the soil health? Those factors are affecting the soil health. If we manage these factors, then soil health will improve and also stop. Those factors are affecting the soil health. Manage that factor in favorable way. First is the reducing deforestation. As I say earlier in my slide, forestation is important for the soil health point of view. So reduce the deforestation. वनों की अंधाधुंध कटाई बंद होनी चाहिए या कम होनी चाहिए ताकि हमारी सॉइल हेल्थ अच्छी रह सके. Land reclamation. Those areas are affected by soil acidity or soil salinity or alkalinity or any other, that land should be reclaimed and convert into arable land, or you can say cultivable land. Soil erosion and soil biodiversity. Soil erosion must be controlled. जैसे कि पहले हमारे समाज में चलन था कि व्यक्ति अपने सर पे एक साफा बांधे रहता था चारों तरफ से, यानी जिस तरह से व्यक्ति के सर पे साफा होता है उसी तरह हमारे खेत पे चारों तरफ मेड़ होनी चाहिए. So soil erosion must be controlled, otherwise our fertile land will run off gradually. Soil biodiversity. Soil biodiversity should be maintained for maintaining the soil health. In absence of sufficient biodiversity, we cannot imagine a healthy soil. So for maintenance of the soil health, it is essential to manage the soil biodiversity. To maintaining the soil health, we can also adopt the conservation tillage practices. Several lot of works on the conservation practices done in India and across the world. We can adopt the suitable practices that can help in soil health maintenance. Reduce the soil disturbance. Crop rotation practices. For maintaining the soil health, it is essential to adopt the crop rotation practices in cropping, in agricultural practices, or you can say in different crop cultivation. Crop rotation is a very costless practice that can improve the soil health without any adding money, without any spend of money. Cover cropping practices, diversified production system, integrate livestock into cropping system. For maintaining the soil health, it is essential to integrate the livestock with the cropping system, or you can say must be integrated with the agriculture and livestock for maintaining the soil health. These are some major driving forces for soil health management. If we manage these things, then we can manage the soil health. First is to burning of crop, stop the burning of crop residues, that will improve the soil health. Use the balance use of chemical fertilizer. Apply the sufficient, or you can say adequate amount of FYM, green manure, different type of compost like vermicompost, native compost, sulfo-nitro compost, phospho compost. Control the soil degradation. Apply the soil test based fertilizer, and also adopt the recent technology, that is the nano adoption of crop rotation and as per land capability. How to measure the soil health? If we convert the unhealthy soil into healthy soils, then how we can say this soil is a healthy soil and that soil is a unhealthy soil. So several parameters, or you can say several indicators, by which we can say this soil is healthy soil and that soil is unhealthy soil. These are the several indicators I have tabulated here for the purpose of measurement of a soil health. The physical indicators like soil compaction level kitna hai, soil work density, dry aggregate size distribution, wet aggregate stability, soil texture, available water capacity. These are the physical parameters. If these parameters in positive way or as per described, then we can say this soil is healthy soil. Similarly, in case of chemical indicator, primary and secondary nutrient concentration, how much they means at least all the primary and secondary nutrients should be in medium condition in healthy soil, at least. Not in higher condition, but always at least should be in medium condition. Similarly, the concentration of soil micronutrients in healthy soils, soil salinity and acidity, soil sodicity, soil pH, EC, and cation exchange capacity. These are the chemical indicator. By these critical limits, we can say this soil is healthy soil. Soil biological indicator, soil organic matter content, permanganate oxidizable carbon content, nutrient mineralization rate, carbon mineralization rate, total microbial biomass, microbial diversity. These are the some physical, chemical, and biological indicators by which we can identify the healthy soil, or you can say by which we can differentiate healthy soil and unhealthy soil. Now, how we can manage the soil health? These are the some points by which we can manage the soil, that are the reduced soil disturbance, crop rotation practices, cover cropping practices to promote plant diversity and living roots, diversify production system, add soil organic amendment, integrate livestock into cropping system, promote diverse plant species with different depth, sustainable animal grazing practices, be patient for the results and don't expect positive change overnight. It is very important. If we are working on to convert the unhealthy soil into healthy soil, then we have a patience, because it is a very long process. Now, these are some strategic framework for effective steps for improving soil health, productivity, and sustainability. These are some activities, or you can say steps by which we can maintain the soil health, productivity, and sustainability. Very first, to enhance the nutrient and water use efficiency. If we wish to maintain the soil health, then it is essential to improve the nutrient and water use efficiency, increase the input use efficiency, adopt the precision agriculture, also adopt the nanotechnology. Now, the nano N, nano DAP, that nano N means nano urea, nano DAP, and nano copper, zinc are available in the market for the application of these particular nutrients. So, adopt the nanotechnology. Fertilizer fortification, integrated nutrient management. These should apply for the enhancing nutrient and water use efficiency. For sustaining the soil and produce quality, to apply the efficient composting techniques and integrated plant nutrient supply system, organic farming, natural farming. For the sustaining soil and produce quality, it is essential to apply organic farming or natural farming, improving soil quality through organic matter addition and correcting nutrient imbalances, development of a workable index of soil quality assessment, imbuing influence of different physical, chemical, and biological soil attributes, understanding resilience of degraded soil, and restoration of their productivity. Soil biodiversity and genomics. Soil biodiversity and genomics can be maintained by the characterization and prospecting of large soil biodiversity, characterization of functional communities of soil organisms, testing of mixed biofertilizers formulation, and for climate change and carbon sequestration, should apply the carbon sequestration research in the context of sustainable management of land and soil resources and conservation and conserving deteriorating environment, conservation agriculture and carbon sequestration, especially in semi-arid and sub-humid regions, tillage and nutrient interaction in soil, crop simulation modeling and remote sensing in climate change research, crop adaptation to climate change, rhizospheric studies. And another is the minimizing soil pollution. Soil pollution can be minimized by bioremedial or phytoremediation of contaminated soils, quality compost production and establishing quality standards, soil waste in waste waters, quality assessment and recycling. On the basis of my previous slides, or you can say my presentation on different aspects of soil health, pros and cons of the soil health, we can conclude that soil health assessment and management will continue to play a prominent role in agricultural production system. Healthy soil is more resilient against fluctuations in growing conditions. With yearly weather uncertainties, the resiliency of the soil system needs to be enhanced to cope with these variations. Building and improving the soil health will ensure continued productivity, enhance farmers' income, and promote food security. Building and maintaining a healthy soil is not an easy task in agricultural production system, especially in the face of drought and other production challenges. With the resolution of the farming and ranching community, it is possible to adopt soil health practices that will maintain and improve soil productivity. Thank you very much.
Thank you, sir. Thank you very much. And you have discussed in detail about the soil health deterioration and their management and what type of management practices we have to adopt to maintain our soil health. And now I request the participant if anybody want to ask anything, any query, any doubt. Anyone? I think there is no question. So once again,
participants should raise questions if you have any doubt and interact with the learned speakers, especially Dr. Pathak, who is heading the Department of Soil Science at Banda. So it will be useful if you have any doubts, you can clear it here. You can write in chat box also so that we can communicate to Dr. Pathak for responding to you directly through email or if the time permits in this present session.
Okay, sir. Thank you very much for inviting me.
Thank you, Dr. Pathak.
Thank you, sir, for inviting me in a prestigious training program as a lecture expert. I am very thankful to the organizer and course director. Thank you, sir.
Thank you. Dr. Rai, please continue.
Yeah. And thank you, Dr. Pathak. Thank you, Dr. Arora. Now we have already discussed many things, how we have to manage our soil health through either putting the organic inputs or chemical fertilizer, either in a organic farming manner or in an integrated manner. So now we will discuss about how we conserve our soil to protect it from the loss of the nutrient and soil both. So for that we have with us Dr. R.K. Srivastava. He is the professor soil and water conservation engineering in division of agriculture engineering, ISCOS, Jammu. And Dr. Srivastava did his graduation and PG from the Pantnagar and MTech from IIT Kharagpur. And he will talk about the soil and water conservation technologies for improving soil health. And he has also assisted with the many DST projects. And one of the project his project is making the success story, which was appreciated by our Honorable Prime Minister in one of his speech, and DST also. So I request Dr. Srivastava, please proceed with their experiences and share the knowledge with the participants. Dr. Srivastava, please.
Thank you, Dr. Rai, for a nice introduction. Thank you, Dr. Arora, Dr. Atul Kumar Singh, Dr. Arya, for giving me opportunity. Good afternoon, participants. Today we will discuss about the engineering aspect of soil and water conservation. So let me share. So it's visual. Hello, Dr. Rai.
No, sir. Doctor, please share your slide. It is not, the slides are not visible. Only files are visible.
But
the file will not slide.
डॉक्टर साहब आप पहले उसको ओपन कर लीजिए पावर पॉइंट को.
हाँ, ओपन हो गया.
ओपन हो गया तो इसको बंद कर दीजिए जो एक्सप्लोरर खुला हुआ है. ये जो आपका फोल्डर खुले हुए हैं ना, इसको बंद कर दीजिए बाकी फाइलों को और फिर स्क्रीन शेयर दबाइएगा.
Let me. It's not visible.
हाँ, अब आ गया. It's okay.
Now screen is visible.
Yes.
Okay, thank you. So we will discuss soil and water conservation technologies for improving soil health. Dr. Pathak has discussed many things about the improving the soil health, and I will discuss about what are the engineering interventions so that we can conserve the soil. And basically, in engineering aspect, basic objective is conservation of the water. When we conserve the water, soil will automatically conserve. And what happens basically, we will talk about the erosion. And major basically soil is eroding annually, year by year, in a great quantity, mainly due to region of gushing speed of runoff water. So how to reduce the gushing speed of runoff water and give more opportunity time to soil so that water get infiltrated into the soil mass. So this is main objective of the different engineering intervention, particularly conservation of the soil. So in this presentation, I will also share the experience of DSC as Dr. Rai discussed. Slide is not moving.
Slide move नहीं कर रही डॉक्टर साहब.
Now it's moving.
Yeah, it is now.
Yeah. As we see, basically, as we know that soil and water is the key input for agriculture development. And the productivity of any area depends upon how efficiently these resources are managed. And if we see Indian context, basically we are having more liability than resource we are having. We share only 4% of water resources globally and 2.5% of area. But we support 16% of human population and 18% of livestock population. That means we are having more liability than what are resources we are having. So there is a need to utilize the resource efficiently. What is the key input? And you see the availability of water keep on decreasing. In 1955, the availability of per capita availability of water was 5,200 cubic meter per person. Now it reduces to around 1,300. At the same time, there is a pressure, there is a demand to increase the production, to increase the productivity due to increase in population. So how we can increase the productivity as quality of water and the quantity of water keep on decreasing, and availability of land is also decreasing. So due to the technological intervention, due to the advanced methods. And if you see the water distribution, whatever the water, agriculture is the major consumer of the water. 80%, whatever water we are having, that 80% of water goes for the agriculture. And out of this, 50% is used for paddy crop only. And industry share is 12% and domestic 8%. And 80% irrigation water and 90% drinking water comes from the groundwater. And same time, water level of groundwater level keep on decreasing. Why? Because the main source of water, groundwater, is runoff. And due to this, you see the retardation of the recharging process, infiltration process, due to construction of road, due to urbanization, so many things. The withdrawal is more, and same time, recharging process is reduced. So average, if you see the average depletion of water annually, it's around 60 to 70 centimeter per year. And some places it is more than 1 meter. You see the example of Maharashtra, you see the example of Haryana, you see the example of Punjab, even some part of UP, Rajasthan, water level keep on decreasing. And water level keep on decreasing, what happens? Instead of centrifugal pump, when we are withdrawing the water for irrigation, we have to go for the submersible pump, and cost of submersible pump is far more than centrifugal pump. So cost of pumping water, cost of irrigation water keep on increasing. You see, you are seeing in newspaper and hello, it's moving.
No, yeah, it's moving, Doctor. Please.
Okay. So you see a number of ponds dried, number of rivers, water of rivers, either river flow decreased or some seasonal, most of the seasonal rivers are dried. This is a report of NEET Ayog. See the fight of water for drinking only. You see the maximum water to produce of 1 kg of paddy, you need 3,000 to 5,000 liters of water. To produce 1 kg of wheat, we need around 2,000 liters of water. And this is a problem of water for drinking purpose. You see the problem of water. You see how people are queue for the taking of water. And you have heard the news in TV that it's around in the year of 2016, the drinking water was supplied through the rail tanker. And this is the condition of drinking water. You see, what about the agriculture? How people are taking risk to get one bucket of water. These are a real picture of Maharashtra. You leave the quality of water. Just to get the one bucket of water, they are trying too much hard, they are taking risk. And I think this water is not potable, not drinkable. Still, people are using this water. The water tanker supplied by the government, they are protected under the guards. See the situation. How much risk the people are taking to just one bucket of water. These are the real picture of Maharashtra. See about the livestock, there's no water. See, people are moving around 4 to 5 kilometers to get just one bucket of water. And if we see the soil erosion, on an average, 5,334 metric ton of soil is being eroded annually, and which is equivalent to 16.4 tons per hectare per year, slightly more than 1 mm depth of soil. And we as we know that formation of 1 centimeter of soil, it takes around 1,000 years. And as Dr. Pathak has said, that only upper layer of soil is fertile. And if upper layer of soil is eroded, then if you pour the high quality of seed or fertilizer, we will not get any yield. So we have to protect our soil, surface soil, by intervention of different conservation measures. And out of this eroded soil, 29% is lost permanently into the sea, and 10% gets deposited in the reservoir. This is very, particularly reservoirs, mostly big reservoirs are dams. They are basic objective to produce the electricity, and they are constructed on the as a certain life by considering the catchment area, that what is the rate of erosion. On the basis of that rate of erosion of that upper catchment, the engineers decide the basically life of that particular dam or storage structure. But during the construction, they have anticipated that particular rate of erosion. For example, they have anticipated 8 ton per hectare per year. And due to deforestation and other human interventions, the rate of erosion becomes double. So the useful life of that particular reservoir reduces drastically, in which we have invested crores of rupees and planned for the designed area for under command of that particular reservoir. And 61% displaced from one place to another. This is also a pathetic situation. What happens during flood and during this erosion process? The eroded soil particles or eroded soil gets deposited in plains, and that fertile soil becomes unfertile. So this erosion basically creates the multidimensional problem. It creates the problem where the soil erode, and it again creates the problem from where its soil it gets deposited. And there are different approach, like one is watershed approach, and another one is cluster approach. And if you see what is watershed? Watershed is the area covered by a ridge line having one outlet. If you see the hill में अगर बारिश हो रही है, तो अगर आप देखेंगे कि एक साइड इधर पानी जा रहा है, एक साइड दूसरी साइड पानी जा रहा है, तो व्हाट हैपेंस, जिस साइड का पानी जिस एरिया को कंट्रीब्यूट कर रहा है, वो उसका watershed area या contributing area कहलाता है. And that contributing area, the water from that contributing area, when passes through a single point, that called watershed, that particular outlet. So outlet that when we will see the catchment area, command area, catchment and command area relationship for a particular watershed or particular water body. Command area, what is command area? Command area is like this: when there is a water body, for example, water harvesting pond or tube well, how much area we are irrigating with the help of that particular pond or particular tube well, that called command area. And what is catchment area or watershed area? How much area is contributing runoff water for that particular water source? for example, pond, that called watershed. You see, delineation of watershed, how we can delineate the watershed. So for delineation of watershed, we need the contour map of the area. With the help of contour map, if you see the characteristics of the contour, then you can identify what is the, where is the ridge line. So this is the ridge line basically. This is the ridge line, and we are delineating it with the help of this contour map. We can delineate the watershed, and particularly suppose that this is watershed. We have delineated this watershed, and this is the outlet. Once you have delineated the watershed area, you can delineate the streams. There may be first order stream, second order stream, or third order stream, and the maximum stream at the outlet, that called that particular stream of the watershed, or second order stream watershed, or first order stream watershed. You see, this is the first order stream, this is the first order stream. And as for Horton approach, when two first order stream meet that particular stream called second order stream. So this is a second order stream. And again, this second order stream, this one is first order stream. So this is again second order stream. When two second order stream meet at a particular point, that next stream becomes the third order stream. So you see, this particular watershed is a third order watershed. So watershed can be a second order watershed, a third order watershed, or fourth order watershed, or fifth order watershed. This is the delineation of the watershed area. You can see for delineation of the watershed, we can get the data, SRTM data from the remote sensing, or we can get these contour map from the topo sheet. We can delineate it, and with the delineation of the contour map with the help of topo sheet or imagery, we can delineate the watershed area. And once we have delineated the watershed area, then we can delineate it into the sub watershed, because for conservation treatments, to treat watershed at a one time is a very difficult task due to constraint of the funds, due to constraint of the manpower. So we categorize the whole watershed into sub watershed. And when we categorize the whole watershed into sub watershed, then there are different techniques, there are different models. We can prioritize these sub watershed, which particular sub watershed is suffering more erosion, so that we can start from that particular watershed. So there are different type of techniques using SCS curve number method, or different models are there. You can prioritize the watershed, and when there is a limitation of the funds or the manpower, then you can start your conservation measures from the most degraded watershed. So these are the watershed area, and these are the streams, like this one is first order stream, second order stream, third order stream, that I have already told you. For conservation treatment engineering point of views, we can categorize in different parts. One is agronomic measures or biological measures. Under agronomical measures, there is contour cultivation, strip cropping, and tillage practices. When the contour cultivation, when the land slope is around 2 to 3%, then such type of agronomical measures we recommend. In contour cultivation, basically we are growing crops along the contours. What are the contours? Basically, contours are the imaginary lines of same elevation. So we are growing the crop along the contours. So what happens basically that runoff water gets retarded due to the construction, due to construction or availability of these contour lines. So it gets more opportunity time to get infiltrated into the soil mass. So we can conserve the water as well as soil. And another one is strip cropping. Basically, we are growing the strips of erosion permitting crops and erosion resisting crops. So this process, we can reduce the erosion and we can conserve the water. Erosion permitting crops, that means cereal type of crops are basically erosion permitting crops, and erosion resisting crops, generally legumes crop are erosion resisting crops. So such type of cropping system basically we adopt when we are recommending the agronomical measures or biological measures. And tillage practices. Tillage practices, basically we recommend such type of tillage practices which can basically reduce the soil erosion, just like a strip tillage, just like a geo tillage. Basically, such type of methods disturb the soil minimum, so that they are just opening that particular soil area when we are performing seeding operation. So due to this tillage practices, we can reduce the soil erosion. Use of engineering practices. Another one is engineering practices. Under engineering practices, basically there are two methods. One is contour bunding and another one is bench terracing. Contour bunding, basically we are recommending up to 6% of soil. These are very effective methods for soil conservation and water conservation, and at the same time improving the productivity when when water gets infiltrated into the soil mass. The moisture regime within the soil mass increases, and due to this, the productivity of the particular crop, particularly in rainfed area, increases. And another one is bench terracing system. Bench terracing system, basically we prefer the where the land slope is more than 6% and up to 50%. Even sometimes we are constructing bench terracing up to 75% land slope. And contour bunding, basically what are the contour bunds? Contour bunds are just these are the mechanical embankments in trapezoidal shape, and we are constructing across the slope. And there are different designs, like what should be the vertical interval, what should be the horizontal interval. So this is a different approach. There are different scientific methods how to calculate the vertical interval, how to calculate the horizontal interval, what is the cost of construction of contour bunding, what is the area loss. So there are standard methods. We can construct the contour bunding on the basis of the soil type, land slope, on the basis of the rainfall of that particular area. So these are the contour bunding. And bench terracing, again, these are the bench type or steps type structure. Basically, when we are modifying the lands, particularly, for example, particular area land slope is, for example, 33%, and we are modifying that particular land in form of steps. And bench terracing, basically three types: inward bench terracing, level bench terracing, outward bench terracing. So what type of bench terracing we should prefer, that depend upon the area where we want to construct. These are very effective, particularly for the hilly region, because otherwise, if we are performing the agriculture operation in slopy land, then it enhances the erosion process. And use of engineering structure. Temporary engineering structure, again, can be categorized in temporary structure and permanent structure. Temporary structure are brushwood dam, loose rock dams, woven wire dams. These are very cost effective and can be constructed the locally available material. And permanent is they are having life of 5 to 10 years. And permanent structure, these are a costly affair and generally preferred to in drainage line treatments. When the erosion reached at final stage, just Dr. Pathak has discussed the erosion, and the erosion, if you will see that there are different processes of erosion. First one is splash erosion. Then if you will not control the splash erosion, then it becomes the seat erosion. And if you will not control the seat erosion, then it converts into the rail erosion. And if you have not taken any conservation measures to control the rail erosion, then it becomes the gully erosion. And when it becomes the gully erosion, then controlling of the gully erosion is costly and time-taking and difficult also. So when there is a seat erosion or rail erosion, then we should start the conservation measures. Technological interventions for the conservation of the soil. There are in situ moisture conservation techniques and ex situ moisture conservation techniques. In situ moisture conservation techniques are those techniques we were trying to conserve the water or moisture, particularly water from the rainfall where rain occurs. We are conserving the rainwater where it occurs. That only that particular field only. How we can conserve the water for that particular area? That with the help of contour trench. With the contour trench, basically, these are the trenches of 0.5 meter width, 0.5 meter depth, and maybe length of 10 meter, maybe length of 6 meter, or sometimes maybe length of 12 meter. So generally, if we are proposing the contour trenches of 5 meter or 6 meter, then these are called split trenching. And when we are recommending the trenches of 12 meter or 15 meter, that called continuous contour trenching. And contour bunding that I have discussed, the contour bunding, these are the mechanical earthen embankment in trapezoidal shape. And bench terracing that we have discussed, these are the three types of bench terracing. And water spreading, just constructing the bunds around the field, and we are basically spreading the water so that it gets infiltrated into the soil mass. And ex situ moisture conservation measures, basically we are diverting the runoff at particular location, and we are utilizing that water for irrigation purposes or recharging purposes. So for ex situ moisture conservation measures, they are rainwater harvesting tank, roof water harvesting system, percolation tank, recharging pool. That means for roof, for example, roof, we are collecting the runoff water from the catchment of roof, and we are collecting at one particular location, either with the help of PVC tank or construction of RCC tank. And rainwater harvesting tank, just like we are collecting the water from a field, from an area at a particular location where we have constructed water harvesting tank. And similarly, percolation tank are recharging. Strategies we can for construction of in situ moisture conservation measures or ex situ moisture conservation measures, like we can plan the water harvesting tank, roof water harvesting system, percolation tank, recharging pit, and earthen embankments, particularly in gullies, gabion structure, the temporary structure, cost-effective structure we can construct in gullies for the recharging process for reducing the erosion. And contour trenching, contour bunding we can construct in the field itself so that we can conserve the soil mass as well as water. I will share my experience. One of the recently completed DST project, basically in Jammu district. We have selected the 3 villages in Jammu district, particularly that particular area lies in Kandi area. As you know, Kandi area have different characteristics, poor soil, boulders, shallow soils, and poor organic matter, and very prone to erosion. And the main basically constant is water. So that agriculture of this particular area mainly depend upon the mercy of rain. If they are, and same time due to slope, due to the topography, the erosion is basically creating the problem. Fertile soil is washing year by year and again reducing the productivity. There is a problem of water for irrigation. There is a problem of water for drinking purpose, you are saying, and there is a problem for livestock purpose also. So there are open wells, and they are just 30 feet depth, and water in these particular wells basically dry during the winter as well as the summer season. So under this project, basically we have constructed different soil conservation measures at farmers' field. We have constructed poly tank, we have constructed percolation tank, we have constructed recharging pit, and for in situ moisture conservation measures, we have constructed contour bunding, contour trenching, split trenching, roof water harvesting system, gabion structure, earthen check dam, and the harvested water which is stored in the poly tank. For utilizing this water efficiently, basically we have installed the gravity feed irrigation system and sprinkler irrigation system, portable sprinkler irrigation system. We have developed a customized kit for a sprinkler irrigation system for an area of 1,000 meters square. That locally called canal, 2 canal, that 1 canal 500 meters square. So this unit is used locally. For small poly tank, basically small poly tank in hilly area, particularly hilly area, to get the flat land again a constant. We can't go for the big water harvesting tank of 400 cubic capacity or 600 cubic meter capacity. So basically, we have constructed 5 number of small poly tank. The storage capacity of such type of poly tank is 100 cubic meter. That means 1 lakh liter. And to make it cost effective, basically the lining material we used the circulating seed. This is 250 GSM. 250 GSM, that means 250 grams per meter square. When GSM becomes more, the thickness of the seed becomes more. And this is a 3-layered cross-laminated seed. It is having life of around 5 to 8 years. So the cost of this particular structure is 50,000. And this is in trapezoidal shape. Top dimension, if you will see, the 9 meter by 9 meter, and bottom dimension of 5 meter by 5 meter, and side slope is 1:1, and depth of this particular tank is 2 meter. These are the action photographs when basically when you are planning to construct a particular tank, then you should, this is very much important. First, you should decide identify the catchment area. Catchment area, whether this particular, when you are deciding the capacity of water harvesting tank, then one must ensure the catchment area. How we can ensure the catchment area? Then there are different models, as is curve number models. There are different methods. Otherwise, thumb rule is that in agriculture land, basically, whatever annual landfall, 15 to 20% you can take for, you can assume for the runoff purposes. When this particular depth of runoff, you will multiply the area, it will give you the quantity of water that you can, that a particular catchment can produce. And accordingly, you can construct the this poly tank at the point of lowest elevation in the field, so that we can reduce the earthwork. And when we are constructed, because we are knowing the top dimension 9 meter by 9 meter, you can demarcate 9 meter by 9 meter to the line. And again, you can demarcate this bottom dimension, that means 5 meter by 5 meter. And with the help of JCB or manually, one can construct the earthen pond with the help of JCB, and finally reshaping of that particular tank with the help of manually. So this is earthen tank. And for laying up the poly seed, we basically construct a trench of 0.5 meter depth and 0.5 meter width along the periphery of the pond. And this is 250 GSM seed. So this is the laying of 250 GSM seed, and this is again covered with the help of boulders and soil. So this is poly tank. And to utilize this water, basically, we have installed a gravity feed irrigation system. I will discuss it later on. And one innovative thing we did basically in this rainfed area, where the evaporation losses are more with compared to rainfall. Average rainfall is 1200 mm, and evaporation is around more than 2000 mm. So when we are constructing these particular tanks and we are putting money, so how we can store the water for useful purpose efficiently. So this innovative technology, basically with the help of farmer participation, we have constructed this 0.5 meter by 0.5 meter square type of grid type of frame with the help of bamboo, which was available with the farmer. And after framing this particular bamboo frame, we have covered this bamboo frame at the surface of poly tank. And this net seed, we have covered this poly tank with the help of net seed, and we have seen there were around 30 to 40% lesser evaporation losses in compared to other poly tank which were not covered. And same time, when we were selecting the sites, suitable site for the construction of the poly tanks, the good site, goods available site, when our technical committee selected, the mostly farmer were not interested to give that particular site, because that particular site is useful for crop production, and our interest was that it should be that area where the farmer is growing crops, so that water for irrigation purpose can be utilized for that particular area. But we ensure that you can utilize this area which you are saying that it is a wastage by growing the vegetable crops around the periphery of that particular structure. And by our suggestion, basically, they have grown the vegetable crops around the periphery of, you see, this these are the creepers, these are the vegetable crops around the periphery of the polytank.
Problem is not all these ideas.
And what happens basically, this surface basically, this is basically we are all utilizing for the crop production. And that particular farmer has taken around 80 kg or 70 kg crop from this particular net area which is covered. And sometimes there is only one PHET well basically supplied for the drinking purposes. And sometimes if there is a problem, then people are taking water for livestock or other purposes from the polytank. And this is polytank, and this one is gravity-fed irrigation system. And see the change of land use. Otherwise, they were growing the conventional crop like maize and wheat. And with the help of available water and this efficient irrigation system, this particular area, they are growing the vegetable crops. So capacity 1,000 liter and cost of this particular structure 50,000. And this is a roof water harvesting system basically. So this is a 2,000 liter PVC tank. These are the very basically easy to construct and leak proof. Otherwise, when we are constructing RCC structure generally creates the leakage problem. So we have constructed with the help of PVC tank. And this water he is using for the kitchen gardening, for growing vegetable crops in kitchen garden. These are the action photographs of the construction of the roof water harvesting system. We have constructed 10 number of roof water harvesting system that particular area. And with the help of this particular roof water harvesting system, people are growing the vegetable crops in their kitchen garden. These are the basically smaller than structure for groundwater recharge. And these structures of 50,000 liter capacity, generally 7 meter by 7 meter, depth of 1.5 meter. And this particular structure, some structure we have constructed at the upstream side of the open well. And as I have told you, the open well basically dry during the summer, winter as well as summer season. And by construction of these recharging structure at the upstream side, after one year, what we have seen that the water level of the open well, every water level of the open well was increased around 1 to 1.5 meter when we have compared the control one, and longevity of water in the open well was increased around 30 to 45 days in a year, in the first year, and second year water was remain available throughout the year in open well. So see, it was a great impact, and we have published this success story in DST. So these are the basically recharging structures. And what happens? The capacity of 50,000 liter, and these particular structure filled in one rainy season around 10 to 12 times. 10 to 12 times. That means 5 lakh liter you recharge 5 lakh liter of runoff water. So again, this is enhancing the moisture regime within the soil mass and ultimately enhancing the groundwater recharge. These are the recharging structures. You see, they dry during the winter as well as summer season, and you see the water level during the rainy season. When we compared the control one, it was around 1 to 1.5 meter above. And these are the in situ moisture conservation measures. In situ moisture conservation, these are, we have constructed the bench terracing, we have constructed the outer periphery bunds, and these are the trenches. Basically, these are the trenches of 0.5 meter width and 0.5 meter depth and length of 12 to 15 meter. And once inner side we are constructing the contour trenching, and outer side we have constructed the contour one. So what happens basically when the runoff occurs? It gets logged into the bench terracing system, and it will get the more time into the soil mass, So what happens basically when we have compared the moisture content in the soil in every 7 days with compared to control 1, the moisture content was found 10 to 15% more in compared to control 1, and productivity of such particular type of field was increased around to 40 to 50%. And same time, what happens when there is erosion? That basically soil gets deposited in this particular trench from the field, and later after 1 year or 2 years, we again spread this particular soil into in that particular area. So we can conserve the soil as well as we are conserving the water. We have constructed the bench terracing also. Here are the contour bunds, and again contour bunds, if top dimension 0.5 meter, bottom width 1 meter, height 0.6 meter. And if you see the cost one can get on the basis of the dimension, we can calculate the cost of construction. This is 30,500 per hectare. And basically benefits: conservation in situ moisture and improving the yield. These are the trenches. Width 0.8 meter, depth 0.5 meter, length 10 to 20 meter, and spacing 6 meters. So what happens in any season or any events of rainfall? Water get accumulated in this particular trench, and the water infiltrate laterally as well as vertically. So it enhances the moisture regime within the soil mass. These are the bench terracing system, and by construction of bench terracing system, we have created 0.5 hectare new land for the construction of the agriculture production. This is the gravity-fed drip irrigation system. Gravity-fed drip irrigation system, we have constructed a frame, angle iron frame of 2 meter height, and at this 2 meter height, 5 meter below the ground, and 1.5 meter effective height to create the head which is required for the gravity-fed drip irrigation system. And this PVC tank of 1,000 liter capacity kept on that particular frame. And we have given the 0.5 HP pump for the farmer to fill water in this particular tank, and when with the help of this height, with the help of the head generated due to the placing of tank at 1.5 meter high, we have installed a gravity-fed drip irrigation system which is running with the help of this head. That means gravity-fed drip irrigation system, we don't need pump. Otherwise, these are the pressurized irrigation system. Micro irrigation system or pressurized irrigation system. So gravity drip irrigation system, these are the very cost effective and can run with the help of gravitational head. These are the action photograph, and this is the frame. And these are the basically drip irrigation system we have installed for a 1 canal area. And due to this poly tank and gravity-fed drip irrigation system, farmer has started around 30 to 40,000 rupees from his field by growing the vegetables. Otherwise, he was just growing the conventional crops like maize and wheat. Thank you.
Thank you. Thank you, Dr. Srivastava. Hello. Yeah. So, Doctor, thank you very much. And you have discussed in detail about the soil and water conservation practices. One way that we have enriched our soil to putting the nutrient in the soil, and another way is to protect the soil loss or nutrient loss from the field. So for that purpose, that soil and water conservation measures adoption is very much required basically in the hilly areas or undulated land. And now it is open for discussion. If anybody have any doubt or any question from participant side.
Sir, I want to add, sir.
I request the participant.
Yes, sir. I am Dr. Vivek Arya, sir.
Yeah, please, sir.
Sir, first of all, I would like to congratulate Dr. Srivastava sir for a very elaborative presentation. And sir, one thing I want to share with Dr. Sanjay Arora sir, that the work which he has depicted was even published in the Technical Bulletin of United Nations, sir. The conference was held at Faridabad. It was then attended by Prakash Javadekar sir. And that bulletin, the work which he has depicted was published by the United Nations workshop on climate change, and now it is also available on website. And fortunately, sir, he has given me the chance to be part of this project, sir. So it is indeed a very, I will say the watershed moment for the Kandi farmer, sir. Congratulations, sir. This was the only comment. Thank you, sir.
Thank you, Dr. Arya. And any participant have any doubt or any query, or because Dr. Srivastava has discussed all the practical aspects, so it is very informative, and anybody want to know detail about it, he or she can talk to him later on through mail or through his phone. So, and Dr. Arora, and maybe he's busy. So now again, I am requesting the participants if they want. Otherwise, we'll proceed for the next one.
Dr. Rai,
Yes.
I think participants should discuss, because we have requested the speakers from different areas, and they should have discussion with them or to sort out some queries or doubts. We can pinpoint some of the participants, the learned participants are there. Madam Indu Chopra.
जी सर,
आज आप कुछ अपने विचार रखें, आज के उसमें कुछ डिस्कस करना चाहें।
सर एक्चुअली मैं सर जो चीजें देख रही थी ना सर, मतलब मैं यही जैसे हिली एरियाज का वाटर मैनेजमेंट का है सर, मैं वही देख रही थी। तो सर कुछ मतलब छोटा सा डाउट था सर, कि सर एक्चुअली क्या है कि अगर हम मैनेजमेंट पे भी जाते हैं अगर वहां पर वाटर का, लेकिन सर जैसे हायर ऑल्टीट्यूड पे जहाँ मतलब नॉट दैट मच हायर ऑल्टीट्यूड, जहाँ पर सर मैं अपना अभी क्योंकि सर मैं होकर आई थी, दलांग गई हुई थी सर, तो सर आई वाज लुकिंग एट द एरिया सर, वहां पर क्या था कि एक पूरा साइड जहां पर सर वो ऑलरेडी क्या कहते हैं अपना फार्मिंग कर रहे थे सर, बिकॉज ऑफ दैट जो आइस जो फॉल होता है, स्नोफॉल होता है उस टाइम पे सर, उन्होंने कहा कि एकदम से वो पूरा आता है और वो खत्म हो गया वो एरिया सर। दिस इज मतलब और इस वक्त पे सर मैन मेड एक्टिविटीज आर सो मच, तो सर हम अभी भी देख रहे हैं बिकॉज ऑफ क्लाइमेट चेंज, हमने वैसे भी देखा बिकॉज ऑफ क्लाइमेट चेंज मेनी थिंग्स आर गेटिंग मतलब आउट ऑफ कंट्रोल ऑफ ह्यूमन, मतलब हमारे हाथ से बाहर जाता जा रहा है। तो सर क्या हम उन एरियाज में अगर हम इस तरह से मैनेजमेंट पे भी जाते हैं तो डेफिनेटली सर कॉस्ट, उस वक्त तो कॉस्ट इन्वॉल्व हुआ, लेकिन जब हम इस तरह के मैनमेड एक्टिविटीज के कारण सर ऐसे डिस्ट्रक्शंस होती हैं तो सर हम कैसे उसको आगे बढ़ा सकते हैं?
ये इंटरनेट प्रॉब्लम थी।
हाँ, कोई बात नहीं डॉक्टर श्रीवास्तव, आपने सुना मैडम की बात? डॉक्टर श्रीवास्तव
सर उनका स्टक हो रहा है।
एक मिनट, अभी एडिट जाते हैं।
ठीक,
डॉक्टर श्रीवास्तव।
हाँ डॉक्टर साहब, डिस्कनेक्ट हो गया था बेसिकली।
मैडम कुछ पूछना चाह रही थी।
हाँ बोले।
मैम प्लीज अगर शॉर्ट में इसको कर ले आप रिवाइज, तो प्लीज रिपीट कर रहे हैं।
Good afternoon, sir. Thank you, sir, for such an excellent presentation, sir. Sir, मैं ये जानना चाह रही थी जैसे हायर ऑल्टीट्यूड्स पे जैसे सर हम करते हैं सर, फार्मिंग करते हैं, एंड वी वांट टू सर conserve the moisture, or we are making the structures for water conservation sir. लेकिन सर जैसे अभी मैं कह रही हूँ कि सर मैन मेड एक्टिविटीज के कारण सर बहुत ज्यादा अभी भी हम सुन रहे हैं क्लाइमेट चेंज के कारण सर बहुत ज्यादा लैंडस्लाइड हो रही है और सर जैसे मतलब पैटर्न चेंज हो गया सर स्नोफॉल का तो सर वो क्या हो रहा है कि कंप्लीट हमारा सिस्टम जो फार्मिंग का सिस्टम है सर मैंने जो खुद देखा मैंने सिर्फ उसके आई हैव वेरी लिटिल नॉलेज कि सर उनका ना सर स्नोफॉल के कारण हैवी स्नोफॉल हुआ सर वो पूरा एरिया मतलब जो फार्मिंग के अंडर आ रहा था सर वो पूरा मतलब उसके खत्म हो गया सर बिकॉज ऑफ दैट सर दैट वाज नॉट फ्रीक्वेंट मतलब पहले नहीं होता था इसीलिए सर वहां पर फार्मिंग कर रहे थे तो सर शेल वी गो फॉर सच स्ट्रक्चर्स देयर जहां पर सर हमारा इन्वेस्टमेंट है लेकिन सर देयर इज चांस टू गेट मतलब अभी चांस बहुत ज्यादा सर बढ़ गए हैं कि सर स्लाइड हो गई या फिर डिस्ट्रक्शन ड्यू टू क्लाइमेटी सर ज्यादा अकरेंस होने लगा है तो सर वहां पर हम कौन से फिर उसके लिए सजेस्ट करना चाहिए सर
Basically, madam, what is happening? You have rightly said due to the climate change and so many things. Basically, what should be the modification on designing up such type of structures? So इसके लिए क्या है कि जो हमें जो एक्सट्रीम इवेंट्स हैं जैसे हम पर्टिकुलर टेम्परेरी स्ट्रक्चर्स के लिए हम लोग 10 years का रेनफॉल डाटा एनालिसिस करते हैं और फॉर एग्जांपल व्हेन वी आर कंस्ट्रक्टिंग द कंटूर बंडिंग सिस्टम we consider the rainfall of maximum 1 day rainfall of last 10 years data ठीक है तो उस डेटा को कंसीडर करते हुए कि हाउ मच रन ऑफ दिस पर्टिकुलर रेनफॉल इवेंट कैन प्रोड्यूस so accordingly what should be the height of that contour bunding structure now seeing the climate change we have to analyze even more than 10 years data for example 20 years data for example 30 years data and should give more freeboard for designing of the structure or some extra safety features for example one day rainfall data for example say 80 mm instead of 80 mm we are considering 20% more 100 mm and we are designing that particular structure whether contour bunding whether bench terracing system on the basis of this particular rainfall event so that it can face the runoff by due to the any event due to the climate change effect.
सर जैसे आपने कहा कि वी नीड टू टेक 20 इयर्स डेटा इनटू कंसीडरेशन लेकिन सर ये जो फ्रीक्वेंसी बढ़ी है सर ये रिसेंट इयर्स में बढ़ी है तो सर उसकी क्या फ्रीक्वेंसी मतलब जो डेटा पॉइंट्स हैं जैसे हम लेते हैं तो शुडंट वी इंक्रीज सर जैसे रिसेंट एक्टिविटीज हुई है जैसे 4-5 साल की हम कहें कि सर बहुत ज्यादा आने लगा है इस साल तो सर बहुत ज्यादा ही नजर आ रहा है सर इम्पैक्ट तो सर ये 4-5 साल का जो हम डेटा लेते हैं शुडंट वी इंक्रीज द फ्रीक्वेंसी ऑफ मतलब डेटा पॉइंट्स जो हम लास्ट 4 से 5 साल में जो इंक्रीज हुए
नहीं वो फ्रीक्वेंसी आप डेटा तो जो पर्टिकुलर लोकेशन का है वो आप ले ही रहे हैं पर्टिकुलर लोकेशन का जो आप डाटा ले रहे हैं बेसिकली जो हिस्टोरिकल डेटा है वो आपको ये प्रेजेंट इवेंट तो आपको ले ही रहे हैं जैसे हम परमानेंट स्ट्रक्चर बनाते हैं फॉर एग्जाम्पल 30 years और 50 years तो उससे क्या परमानेंट स्ट्रक्चर बनाते हैं तो हम 50 years का डाटा लेते हैं अब 50 years का डाटा लेते हैं तो उससे क्या होता है कि हमारी कॉस्ट ऑफ कंस्ट्रक्शन बढ़ जाती है फॉर एग्जाम्पल 50 years में एक इवेंट ऐसी आई जो जिसका रेनफॉल दूसरे इवेंट से 50% ज्यादा था अब उसको कंसीडर करने के लिए आपको जैसे हम फ्लाईओवर बनाते हैं तो हाइट ऑफ दैट पर्टिकुलर फ्लाईओवर वी हैव टू केप लार्जर हो सकता है वो 1.5 गुनी हो जाए या डबल हो जाए उसके बनाने से क्या होगा कि उसकी कॉस्ट जो है डबल या ट्रिपल हो जाएगी तो ये कॉस्ट कंसिडरेशन होता है बेसिकली तो हमें क्या है कि जो लार्जर डाटाबेस यू आर सेइंग दी you are rightly saying we should consider the more frequency we should consider the data of other surrounding station also not that particular station where we are going to construct these measures even surrounding station so we can get the good average and we should give some extra freeboard for safety measures this may be the one of the solution otherwise we will go the extreme events are larger data then the cost of such type of structure will be more.
Yes. Thank you so much.
Yeah, thank you.
Anybody else? Okay, I think no once again, thank you, Dr. Srivastava.
Thank you,
very
sir.
much for a
Thank
nice
you.
practical aspect discussion on soil and water conservation measures for improving the soil health. So thank you very much. Now,
Thank you, Dr. Rai. Thank you, Dr. Arora and Arya for giving the opportunity to interact such wonderful people. Thank you very much.
thank you, Doctor. Now, Dr. Arora.
Yes, Dr. Rai. Actually आज का शेड्यूल देखे हैं तो वी आर एट द एंड ऑफ द टुडेज टेक्निकल सेशन. सो डिस्कशन ज्यादा हुआ नहीं, कोई बात नहीं. जो लोगों की क्वेरीज रह गई वो अगली ट्रेनिंग में पूरी करेंगे. अभी evaluation quiz I will be displaying the in the chat box the evaluation quiz link. Every participant should fill this form. It is a evaluation form as well as some questions on the quiz. It is also sent on your email just now. So it is for 15 minutes. You have to attempt it, and then we will be back within 15 minutes. Those registered participants will get it on their mail also. Just I will be sharing the link in the chat box. This is the link I have shared in the chat box. You should fill the form and do all the formalities to get so that we can get the feedback from you to improve upon. And on your email also we have sent it just now. For 15 minutes it is open, and thereafter we will close. Meanwhile, I will be I wish to inform that in the valedictory session, our chief guest is Dr. Pradeep Kumar Dey. He is a program coordinator at Indian Institute of Soil Science, Bhopal, and Dr. Y.P. Singh is our guest of honor. Dr. Y.P. Singh is eminent agronomist, a fellow of NAS, and he is recently retired from ICR CSSRI. So we will be having his blessings and words regarding the and suggestions also to improve upon in our future programs. As the Academy of Natural Resource Conservation and Management is thinking to organize a series of such training programs on different aspects, not only soil, water, crop management, as well as forest ecology and environmental management. In days to come, our members, our active researchers and academicians will take this responsibility to organize such events to share the knowledge, and so that the participants, especially the young professionals, students and researchers, can get an overview, insights and future thrust areas and the idea about what are the recent advances in these themes. So meanwhile, the participants are busy in filling up the evaluation form and attempting the quiz. It is a very brief quiz, just to get the idea what the participant have learned. No
So may
need
I
to
say something?
Yes.
सर आपने जो ऑप्शंस दिए ना सर, which lecture did you like the most? सर उसमें मल्टीपल ऑप्शंस रखना चाहिए था ना सर. सर उसमें सिंगल ऑप्शन है सर.
नहीं, आप देखेंगे नीचे.
नहीं सर, जो लेक्चर्स का आपने दिया ना कि ऑन डे फर्स्ट एंड डे 2 सर, उसमें सर सिंगल पे मैंने मल्टीपल पे क्लिक करने की कोशिश की, इट वाज नॉट हैपनिंग सर.
तो मल्टीपल वो लाइक द मोस्ट था ना.
हाँ सर वही कह रही हूँ बट ओवरव्यू सर इतने मतलब ओवरऑल इट वाज सर वेरी डिफिकल्ट टू चूज दैट्स व्हाई आई वाज लुकिंग कि सर मल्टीपल ऑप्शंस होता तो बेटर रहता सर.
चलिए अगली बार वो भी सोचेंगे, पर अभी तो आप
हाँ,
एक कोई चूज कर लीजिए और बाकी लास्ट में अपने कमेंट्स में लिखना चाहें तो कर दीजिए, वो तो हमने ओपन रखा है.
जी सर थैंक यू सर.
मैं पार्टिसिपेंट्स को भी कंग्रेचुलेट करूंगा कि उन्होंने बड़ा एक्टिवली पार्टिसिपेट किया और जो है बहुत कम डिस्टरबेंस देखने को मिला एज कंपेयर टू अदर प्रोग्राम्स. पार्टिसिपेंट्स कभी कभी अनम्यूट रहे तो ऐसी प्रॉब्लम आई, पर बहुत ज्यादा डिस्टरबेंस नहीं हुआ ओवरऑल. सो वी आर थैंकफुल टू द पार्टिसिपेंट फॉर मेंटेनिंग द डिसिप्लिन एंड ethics during the technical sessions. You will be receiving the certificate soon, maybe in 5-6 days. We are preparing it, and those who have we have the attendance from the Zoom. Those who have joined for more than 75% of the time will receive the e-certificate, and for the others, we will look and ask for their means the absence response, means why they were absent. If the reason was genuine and they have at least attended up to 50% of the time, then we will consider, but not less than that, because uh, training means if you have registered means you should be attentive, you should be there, because the speakers, they have prepared, they have done a great job by preparing the slides, devoting their time and energy for your means knowledge sharing. But if the participants doesn't turn up, it is difficult for us to uh, say something, means it will be difficult for us to share the certificates. अगर कोई मेरी इस बात से असहमत हो तो बात रख सकता है अपनी.
I think all are busy in filling the question. That's why they will be available after 15 minutes.
Submitted sir.
Thank you.
Dr. Bhagavati.
Sir, good morning, sir.
Good afternoon. Good afternoon. How are you?
Fine, sir. Fine, sir.
So you like the training and put up your comments in the that evaluation form so that we can improve upon that.
Okay, sir. Now we are filling, sir. We are filling the format, sir.
Okay.
Okay, sir. Thank you, sir. Thank you.
Thank you.
कुछ खाया खा के आ जा तेरा खा के आ ठीक है आ जा जल्दी
Dr. A.K. Tiwari.
Sir, after this 15 minutes, there will be a break, sir?
No. We will be continuing with the valedictory session as Dr. Pradeep Day will be joining just
Okay.
in a few moments.
Yes, sir. That I know, sir. Okay, sir. Okay.
Dr. A.K. Singh, sir. Can you call Dr. Pradeep Day to join so that we can start just after this? At present, the participants are busy in filling the form. Means 2 minutes are left. So after that, we will be starting the validity program.
Okay. डॉक्टर अरोड़ा
जी
ज्वाइन कर रहे हो
ठीक
we can also take some feedback during this session from some of the trainees participants.
just after
when Dr. Day joins.
Yes, sir. That is a very good idea, sir. If some of the participants are giving some feedback, that is good.
So, dear participant, we are closing the evaluation form. I think we have received 77 responses till now. Out of the 84 participants, so dear participants, now we close the response sheet of evaluation and quiz. It is now no more active, so you should be back in the session with we are moving towards the validity session. I think Dr. Pradeep
I'm
has
here.
joined.
Yeah, yes, Dr. Saab.
Thank you, sir. Thank you for joining.
Good
So I
afternoon.
request, as per the program, our chief guest is with us, and our guest of honor, Dr. YP Singh, is also with us. I request Dr. Pradeep Kumar Rai from Squash Jammu, who was the course director in the program, sir, for the information of the chief guest. Sir, we have organized this 3 days training program, and from different areas, we have covered different topics. The resource person from northeast, from north to south, we have tried. The eminent speakers were present, and we have 240 participants registered. And at present, there are 84, but they were coming and going. Maybe but we have got good response. More than 100 we were maintaining for most of the time. So I request Dr. Pradeep Kumar Rai to kindly start.
Thank you, Dr. Arora. Respected Dr. Pradeep Day, Project Coordinator, Indian Institute of Soil Science, Bhopal, and Vice President of Indian Society of Soil Science, today's chief guest, and guest of honor, Dr. YP Singh sir, is the Senior Vice President of ANRCM, and Dr. AK Singh, President ANRCM, Secretary Dr. Arora, and coordinator of this program, Dr. Vivek Arya, and other resource person and participants. Very good afternoon to all of you. Sir, we have organized this 3 days training program from September 25th to 27th on soil health management, concept and practices. Sir, very overwhelming response we got from the participants. More than 250 participants joined online. And we can say that is participants from Kashmir to Kanyakumari. we can say, because all the states, from all the states, the participants were joined. Likely maximum participants from Uttar Pradesh, that is 48, from Jammu and Kashmir 25, from Punjab 20, Madhya Pradesh 18, Rajasthan 17, and like this in all, Jharkhand, Bihar, Meghalaya, Kerala, Tamil Nadu, Odisha, and from all states we got the participation. And we have organized total 13 lectures, and our resource persons from the CSSRI Lucknow, BAU Sabor, JNKV Jabalpur, Assam Agriculture University Jorhat, ISCOST Jammu and ISCOST Kashmir, Banda Agriculture University Banda, and ND University Ayodhya, and Central Agriculture University Barapani. And the lectures were comprised, the topics of the lecture was that overview of soil health management, that was delivered by Dr. Anshuman Kohli. Methodology for soil health assessment, that was by Dr. Sanjay Arora. Use of biochar for sustainable soil health by Binay Kumar Medhi from Assam. And biofertilizer for soil biological quality improvement, that is Dr. Vinod Kumar from ND University. And we discussed advances in soil physical and chemical quality management, that was by Dr. Sanjay Swami from CAU Barapani. Soil resource conservation from Dr. H.K. Raya from JNKVB. And we have also discussed the use of nano fertilizer in soil health management by Dr. Nentu Mandal from BAU Sabor. And role of agroforestry in soil health management was discussed by Dr. Puneet Chaudhary from ISCOST Jammu. And carbon sequestration and soil health management discussed by Dr. Vivek Amaria from ISCOST Jammu. Balanced mineral nutrition for soil health management was delivered by Dr. Aziz Mustafa from ISCOST Kashmir. Organic farming and soil health was discussed by Dr. Vikas Sharma. He is the professor at Soil Science ISCOST Jammu. Soil health deterioration and their management was today's lecture, was delivered by Dr. Jagannath Pathak, professor and head Department of Soil Science from Banda Agriculture University. And in last, soil and water conservation technologies for improving soil health discussed by ISCOST Jammu engineer R.K. Srivastava. He is the professor in ISCOST Jammu. Sir, in spite of this is the national training program, but the international participants were also joined in this program from Iran and other countries. And more than 200 out of 250 participants, 218 students, and more than 35 faculty members were also participated in this training program. And the scientists from universities, different universities, research institutes, and research stations and KVKs were participated in this program. And some of the participants were very enthusiastic and participated in the interactive session. So this is our side from training program, and we tried our lot to discuss about not only the theory but practical aspect also. In the last lecture delivered by Dr. R.K. Srivastava is totally what we have done in the field, and the success story he discussed, that success story was appreciated by our Honorable Prime Minister also. So this is the whole, sir, all of the training program. Now over to Dr. Arora.
Thank you, Dr. Rai, for giving the proceedings of the 3 days national training program. I, on behalf of ANRCM, welcome the guest, especially Dr. Pradeep Dey, who has spared his valuable time. He has to go somewhere, but we have requested him to be the chief guest for sparing some time from your schedule. Dr. YP Singh, I am thankful to him. He was continuously with us and guiding us every time for improving upon the activities. Dr. Pradeep Dey, as you must be aware that he is eminent soil scientist and working in he has worked in several institutes. He has experience in many capacities. He has worked, and presently he is heading the All India Coordinated Project on STCR, and he is actively engaged in their activities and also support us whenever we require his help. So we are thankful to you, sir, for sparing your valuable time. I request Dr. YP Singh to, as a guest of honor for today's program, to present his address. Dr. YP Singh, sir.
Thank you, Dr. Arora sir. Can you hear me?
Yes,
sir.
आवाज आ रही है?
Yes, sir. Yes, sir.
Yes.
Thank you, Dr. Arora sir. Respected Chief Guest, Dr. Desab, respected Chairman of the Society, ANRCM, Dr. A.K. Singh Saab, Course Director, Dr. Rai Saab, my colleague, Dr. Sanjay Arora Saab, and all participants. I'm highly thankful to the organizing committee for giving me this, once again giving this opportunity on a very short notice that I have to say something about the training program, which was scheduled very nicely. When we were planning, friends, when we were planning about this training program, we were very much worried about the concern and you can say the specialized resource person in the field of soil health management. But I am thankful to the organizers, especially Dr. Rai and Dr. Sanjay Arora and Dr. A.K. Singh, because of their efforts. The selection of resource person was really very nice, or I can say that they were very intellectual, or they were very specialized in their particular fields. So now I come to the topic that the topic which chosen to deliver during this training program covered, I think, most of the soil health management and issues related aspects. I think nothing is left what is soil health, what is the status of our soil health, what are the causes of soil health deterioration, and how can we manage these causes, and how can we improve our soil for soil physical properties, chemical properties, biological properties, and nowadays, and all these aspects are covered in this training program. Another the important thing which I understand during this training program, that although it was the PowerPoint presentation, but I understand on the basis of the feedback from the participants, it was really looking like a lecture in the classroom. The participants were discussing in detail. They were interacting with the resource persons like they are sitting in the classroom. So a lot of questions they have asked, and I think it means that they are enjoying. Participants are enjoying, and they are taking keen interest in all the aspects covered in this training program. So that is we can say this is very important, that the theme, that the objective which we took to organize this training is fulfilled. I can say very well that the objective to, otherwise this such type of training are organized in a classroom or in a physical mode, but this is our that's why we were a little bit scared that what will be the feedback of the participants. But the practical aspect which we covered, like Dr. Anshuman Kohli, he taught like anything, that the students are interacting with Dr. Kohli. Similarly, Dr. Sanjay Arora, Dr. Mehndi, and Dr. Vinod Kumar, Dr. Sanjay Swami, they all. That's why at the time of planning this training, I proposed to the organizers that we have to select the resource person from the universities, or we can say that those who are involved in the teaching aspects. I proposed to the organizers, and they considered my request that most of the resource persons, but not researchers. They were not only researchers, they were researchers as well as they were the teachers also, good teachers. So this I'm highly thankful to the team which selected Dr. Rai and Dr. Kohli and Dr. Vinod Kumar and Dr. Chaudhary, Dr. Vikas Sharma. They did really, they are very good teachers, and they prove it that that's I can say very without any hesitation. So friends, this training in this training they covered the biochar, importance of biochar. Early, the most of the students, and this is our new idea or new concept to maintain our soil health. The biochar topic covered by Dr. Mehndi, really it was wonderful that how best we can utilize that biochar and how with cost effective technology how we can improve our soil. Similarly, and the biofertilizer nowadays, our government is emphasizing, everybody is talking about organic farming, natural farming, and so the topic, the role of biofertilizer in improving our soil health, Dr. Vinod Kumar elaborated very nicely in a detailed. And because nowadays I am working in this field after retirement, I have an assignment to work on organic farming. So I was very enthusiastic to learn and know many things because I'm not man of organic farming. I was just throughout my life I worked in salinity management, so salinity and sodicity. But it was very interesting subject for me. So with this, I can say that most of the things, similarly, soil conservation aspect nowadays, the soil, there are land degradation is becoming a very important issue. So Dr. Dr. Srivastav covered really very good work, very good delivered lecture and covered all aspects how we can conserve our soil. And similarly, the resource conservation. Now, this is also a new area of research. A lot of research is required on soil conservation to improve our soil health. So Dr. Rai covered this aspect. So with these words, I can say that none of the aspect is left over in soil health management and related issues. And with these words, I thanks to the organizer and to Dr. Rai, who is the post director of this program, Dr. Sanjay Arora, Dr. A.K. Singh, and all organizers, Dr. Kohli and Dr. Vikas Sharma, and many more, those who are eminent speakers and involved in the team. So with this, I thanks all of you for giving me this opportunity. Thanks to all once again. Thank you very much.
Thank you, sir. Thank you for your valuable remarks, and your suggestions are highly appreciated as you meticulously give your suggestions. Thank you. So, sir, before listening to our chief guest, I will be requesting the participants to give your feedback in 1 or 2 minutes. Any participant who wish to give the feedback? Already they have filled the form, feedback form we have circulated, but for the sake of the information to the chief guest, any participant?
So everything you said, everything you presented to us, it was really wonderful. It was really interesting. As I'm a botany student, so it was really interesting and informative. It was it was so good. Even though I was doing classes, I still got time to listen to you, and it was really wonderful. Thank you.
Thank you. Dr. Mishra?
Yeah, Dr. I think, am I audible to everyone?
Yes.
Okay, Dr. Thank you so much for this wonderful event. And I can say, like, this is more or less, we are doing the training. So I haven't feel like it is online. I thought it is virtual. So very wonderfully explained, and all is in pictorial form. The PPTs, the presentations were very nice. I think one thing that we all should know, and we also realize that in last 2 decades, our soils are really degrading at a vaster pace. What we as an individual can do, if we see like how we can use our resources efficiently, how what we are harvesting, how we are reverting back or putting back to our soils, that is crucial. And biochar is one of the ingredients that you mentioned. I think the dilemma for any young researcher is, how do they define soil as a quality or soil as a health? I think this training will help them to segregate like what is health aspect of the soil and how they can relate the quality aspect of the soil. And I think this is very crucial to take it forward as a research organization or as an entity or for the national soil health builder. So even Sadhguru, if you see the initiative, Save Soil, so people are coming forward, and I think this is the right move. And with the team that you lead, it's really wonderful. We learn lots of things on soil health, carbon sequestration, agroforestry, forestry-based systems, and how nature-based solutions should come forward. I think the regenerative agriculture people are talking about. People are talking about nature-based solutions. And I think the last thing that I can say is thank you everyone for being coordinating this wonderful session. And please spare some time to visit our ERI South Asia Regional Center that is based in Varanasi. And we are doing on soil health aspects. We are having natural fertilizer unit. We are trying to evaluate and understand like why this the 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 dilemma in the fertilizer, basically organic fertilizer. There is no standard protocol. Can we make it with the NAS partners? How we can see it forward? What are the low cost organic inputs that can farmer take it? And that too for the context specific and site specific management. So this is all from my end, Axab. A wonderful initiative, and I believe like such initiatives you will definitely contribute in the future. Yeah, Axab, over to you.
Thank you, Dr. Mishra. Muchadia Ravindra. Do you want to speak? Any means you can also give us the suggestion for improvement. Dr. Bhagwati.
Sir, good afternoon, sir. Thank you very much for the nice training organizing, sir. Actually, the 2 lectures. The first day, the lectures, methodologies for soil health assessment. And another one is organic farming and soil health. The slides are very good, sir. Can you able to spare the material and this training materials to our mail, sir?
Yes, thank you, Dr. Bhagwati. We have compiled a training manual also, and we will be the whole of the training was for the benefit of the participant. I want to inform that the complete training is available on YouTube at our channel. ANRCM Lucknow is our channel. You can see the videos. Your presentation means your discussions, everything. It is live, going on live on YouTube, and this presentation is also live on the YouTube. Thank you.
Okay, sir. Thank you, sir. Thank you so much, sir.
Any other participant? Anjali? So, thank you, participants. Before I request our chief guest for his address, I request him to kindly release the cover of the manual, the training manual, which we will be sharing with the participants. Dr. Desab, kindly release by just giving your words.
I think this soil health management concept and practices, editors says it all. I know all of them personally, and I'm sure that it will be useful for all the trainees, not only this particular training, but in the times to come, this can be used for future training also. So I'm happy to release this digitally. Thank you very much for giving this opportunity.
Thank you, sir. We will be sharing the soft copy of this with all the participants, and it will be available on the website of Academy, www.anrcm.org. So we are in the final moments. I request our chief guest, Dr. Pradeep Dey, to kindly address the gathering.
Okay, thank you, Dr. Arora. My senior, Dr. Y.P. Singh, guest of honor today. I think it is a role reversal kind of thing. He should have been otherwise, but it's a good opportunity for me to interact in this program. Dr. A.K. Singh Sahab, the president of the academy, Dr. Arora, Dr. Rai, and all others whom I know personally, they are all very established in their field. So the feedback from different trainees that I have heard, as well as I was going through also the chat, and they were telling that all the sessions and speakers are fabulous like that. So it shows that it has done very well, and really happy to join this particular program. So starting with the soil quality and soil health, as these two concepts sometimes people get means take it reversibly, but there is of course very subtle distinction. To sustain the biological productivity, maintain environmental quality, promote plant, animal, and human health, these are the common for both the things. Within the ecosystem and land use boundary, this is also common. Only thing is, what is the basic, very finer difference in soil quality is the capacity of the soil to function, and the soil health is continued capacity of the soil. Means a sustainability part is actually attached, then it is soil health. So basically soil quality is dealt by scientists. They arrive at different parameters and then zero down either through principal component analysis, PC 1, 2, 3, 4, taking out 2 each from under each PC principal component, and then zeroing down and then attaching some expert based rating to narrow down to about 5 parameters. That is the usual case for the soil quality index development. Soil health is a more common man's language, and people understand whether soil is good or bad by this. So this is just one difference. Another is the soil. This one is called soil function. Actually, in soil quality, there are different functions of the soil that goes along. So soil biodiversity and productivity function, usually these two we deal with. Productivity function is yield and biodiversity attached to that. And usual indicator for this is soil organic carbon, nitrogen, sometimes, many times it is bases, and EC in case of salt affected soil, especially saline soil, pH in case of sodic soil, and then plant available water. This is also another indicator usually attached to it. Then soil and any problem with the audio? Is it audible?
Audible, sir, audible.
Okay. Soil, water, and solute full flow, tillage, aggregate stability, porosity, bulk density, and structure. Basically, these are usually attached indicator to soil, water, and solute flow, soil function part. Then filtering and buffering is another soil function. Soil organic carbon again stand here, texture, CC, and many times we have found soil microbial biomass carbon and basal respiration. These are properties attached to filtration and buffering. Nutrient cycling, again, apart from soil organic carbon and nitrogen, where many a time potential mineralizable nitrogen, soil microbial biomass carbon, these are also attached indicator. And structural support, another sixth one, soil function, usually soil structure, texture, bulk density, and water stable aggregate. These are indicators. So if you look into whole indicators, usually soil organic carbon is called the key indicator in the soil function, and that's why it is called master indicator also. So another one is soil, these chemical attributes. Basically soil quality is governed by, you are told clearly, it was mentioned by our Dr. Y.P. Singh Saab also during his address, that chemical attribute, physical and biological attribute, all the three things should be taken. But usually we attach more importance on chemical attribute, physical and biological are ignored. That's why usually the soil resilience part, which is soil resilience is a term which mainly tells how soil can bounce back if there is a shock. If there is a shock, then soil function goes down. So if you withdraw shock for a long time, it will bounce back and go to its usual function. But remember, it cannot go to its original function level until unless we do something which is actually some offset management practices. That is the thing. So that's why it is important to go, if you want to go back to the original soil function level, then you must adopt some offset management practices. And some of those are, say, conservation agriculture, biochar was also mentioned, composting was also mentioned. Organic carbon can find three pathways. Number one is composting, either it's vermicomposting or say enriched compost, phosphosulfonitro compost, those type of compost or native compost, any type of composting. Number two is conservation agriculture, where we anchor residue or retain residue and then we disturb soil minimum and then follow a proper cycle of crop or crop diversity. So that is the thing. And third part of organic carbon is biochar part. So usually all the acid soil, because biochar pH is a bit high, that's why all acid soil, biochar can be a good part of soil organic carbon sequestration. Then everywhere composting can be there. And soil conservation agriculture, as far as possible, it should be done. We have seen that even in in our kernel experiment, we have seen that reclaimed sodic soil, even in saline and sodic soil, this proves to be very good conservation agriculture. So about 234 million ton of residue that is available out of 650 plus million ton of total residue. So about 1/3 is available. So that 1/3, in which part, how much has to be given, that can be a researchable issue as well as a brainstorming issue. That in which area that this biochar should be more followed, which area this conservation agriculture can be more followed, and in all areas, of course, some part of composting can be followed. So all the three we can segregate and do something. Another thing I would like to mention is soil sickness part. In soil, there are three distinct phases of sickness. Phase one is actually very slowly it goes down, and it is very easy to go back to original level because slope is less. So it is like a rolling a cylinder back to the hilltop, and it is easier if the slope is less. But if the phase two is very steep slope, so it is very difficult to go back to the original slope, and phase three is a stabilizing phase. So once it is attained, then it has gone down to degradation level, and it is very difficult. So we have to check to the phase one level, and soil testing based approach, STCR based approach, or soil test based fertilizer recommendation, indicated fertilizer recommendation is indicated plant nutrient management is the way to restrict to phase one. Conservation agriculture is another way to restrict it to phase one. That's why it has to be followed. And another thing I would like to say that this GPS and GIS based soil fertility mapping, from there we can see whether soil is degrading, degrading or sustaining, and based on that we can choose our which is the option is better and apply that. Another one is soil quality, that rating based system. I'd like to mainly highlight the Muller et al. First developed this in 2007, a comprehensive soil quality rating, and later on that was improved upon. Basically, they do in 3 steps. First of all, they do basic soil indicators like substrate, then soil horizon, topsoil structure, soil subsoil compaction, rooting depth, then profile moisture, then wetness or ponding and slope and relief. These are the basic indicators, about 8 indicators they take. And then soil hazard side by side, they also take, like whether there is contamination, whether there is salinization, solidification or acidification, low nutrient status, very low nutrient status, drought is prevalent or not, then flooding is occurrence of flooding, all these things are taken. So some hazard and some basic soil indicator, those two, first one, basic soil indicator, those are basic soil score about 0 to 34, basically it was suggested. They were weighted based on 1 to 3, and then all the basic score is on the weight basis. and multiplied by weight, those are taken as one indicator. Then from the hazard, second indicator is developed with the weighting, and then both are taken to develop a comprehensive indicator for cropping and permanent grassland. Those who are interested, they can go for this type of comprehensive soil quality rating based system, and they can go for that. If not possible, then what we do in soil testing laboratory, PHEC, organic carbon, then available nitrogen, phosphorus, potash, and some micronutrients, zinc, copper, and manganese, and boron. That 12 parameter that is given in soil health card. Basically, if you do this, we have seen that you can ascertain about 2/3 of total variability, about 65% you can capture, about 15% by organic carbon, nitrogen about another 15%, then available phosphorus, potassium 10%, and micronutrient 15%. About for 65% you can capture. So if you want to enhance this, then you have to integrate physical and biological parameters, 2 parameters each. Maybe bulk density, maybe texture, maybe water holding capacity, maybe water stable aggregate. For biological part, maybe it is microbial biomass carbon or carbon stock of the horizon, some or dehydrogenous activity, maybe any 2 parameter you can decide. So you can ascertain another 35% variability that is not captured by these 12 parameters. So by that way, you can improve upon soil quality index. These are the some of the things that I thought that important. And number 2, active organic matter and stable organic matter and their differentiation, how they can improve on soil quality. That is also very important. Third one, it is very that ecosystem services, provisioning food feed fiber, that is first approach. So this is actually comprehension of 4 different approaches. First is provisioning approach, that is provisioning of food feed fiber. Then your controlling approach through carbon sequestration, mainly in agriculture. Then support service, that is through nutrient cycling, and cultural aspect, like if you can give a good yield to the, we have seen through tribal subplan or schedule type component of our SPCR and other projects, that if you give a good yield and a remunerative yield to the tribal farmer, they stay back to their own villages and perform their own art and culture, and that's why they can proliferate their culture. So all the 4 ecosystem services can be touched upon by this type of thing. And also our Dr. Arora, Dr. A.K. Singh Saab, and Dr. Y.P. Singh Saab, they are very convergent with this. What I am going to talk is poor quality water, use of sewage water, and then how soil quality may be maintained. We have seen that use of sewage water can help saving about 50% of N and P. But there are some salmonella problem and other problems, those have to be taken care of. So if you go by subsurface drip irrigation and then through dilution of sewage and then check timely some of the this other thing like salmonella and all, then this can be a very well resource for water as well as nutrient. And some other aspect like removal of outer leaves of cabbage, growing on raised bed, washing with fresh water and drying in sun or shade. Based on that, we can use the wastewater in a wealth manner. So waste or wealth depends on our ability to manage water, poor quality water, and manage the soil health. So this is another dimension of soil health where we can use wastewater as well as maintaining soil health on long-term basis without deteriorating human animal health. So this is the another part. So this is in nutshell. I think most of these things have already been covered, and there are a lot of other aspects also. And as I was getting from the body language of different participants as well as their chat presentation, I'm sure that this academy is doing a wonderful job. And before ending and thanking the organizer for giving me this opportunity, one appeal I would like to do for all the juniors particularly, because Dr. Y.P. Singh already retired, Dr. A.K. Singh, myself, Dr. Arora, we are going to retire one after another shortly. So it is your academy. Be the member of this academy. Take it forward. Thank you very much.
Thank you, sir, for your valuable suggestions as well as your comments and technical comments, especially on soil health management and overview on the how we can proceed further in managing the soils. We are really thankful to you for your valuable time and giving your insights on the soil health. So before we propose formal vote of thanks, I request all the participants to keep their video on so that we can have a screenshot for like a group photo. Please put your video on for a few minutes. Dr. Rehana, Naeem, Amit Kumar, please put your Bhagwati, Dr. Bhagwati, you can put your video on just for a fraction of time so that Dr. Rai will be having a screenshot. Okay, Dr. Rai, please. Okay, thank you. So I request Dr. Vivek M. Arya, who is course coordinator, to propose vote of thanks to the guests and participants.
Sir, thank you very much. Am I audible, sir?
Yes, yes.
Okay. Sir, on the behalf of Academy of Natural Resource Conservation and Management, for these 2 days training program, that is the theme was soil health management consent and practices. I am highly thankful to our inaugural session where Dr. A.K. Patra, the worthy director of Indian Institute of Soil Science, he was the chief guest and he started this function. We are highly thankful to Dr. Pradeep Dey. He is the project coordinator of soil test crop response and he's also from Indian Institute of Soil Science. I am highly thankful to Dr. Y.P. Singh, his fellow nurse and vice president, and he has been a guiding force to all of us in this academy work. I am highly thankful to Dr. Atul Kumar Singh, a force to reckon with. Working with him in this academy definitely give us many avenues and many ideas on which we are working, sir. And I am highly thankful to all the speakers, especially Dr. Anshuman Kohli, Dr. Binoy Kumar Mehdi, Dr. Vinod Kumar, Dr. Sanjay Swami, Dr. H.K. Roy, Dr. Puneet Chaudhary, Dr. Neetu Mandal, Dr. Aziz Mustafa from Srinagar, Dr. Jagannath Pathak, and Dr. R.K. Shrivastava for their valuable lectures during the 3 days training program. I am highly thankful to many of my seniors, especially Dr. Vikas Sharma, he's professor and head, Dr. P.K. Rai, he's the director, Dr. A.K. Mishra from Erie, and overall I am highly indebted to Dr. Sanjay Arora sir for his constant encouragement and guidance for all the activities carried out by Academy. And once again, I am highly thankful to the huge response which we are getting across the country. For this, it was not possible beyond the comprehension of Dr. P.K. Rai and Dr. Sanjay Arora sir and Atul Kumar Singh. We are indeed indebted to all the respected participants who have given us very valuable information. The link which was shared by Dr. Sanjay Arora sir a few minutes back. Once again, I am highly thankful to all the learned speakers, and we look forward that the Academy is going to have a physical training program very shortly, as discussed in the last meeting. And I request Dr. Dey and Dr. Patra Saab to kindly bless the Academy in future also. And I beg to differ that you are going to retire very shortly, sir. You all are the rising star of the soil science. Now I think the soil science has got some opportunity at the ICR, sir. So my best wishes are all with you. With all this, I conclude this training program, and I wish all the best to the future of the students who have participated. Thank you very much for giving me the chance. Thank you, Sanjay Arora sir. Thank you, Dr. P.K. Rai.
Thank you, Dr. Arya.
Thank you. Thank you. Happy Navaratri to all and happy Puja, Durga Puja to all. Thank you very much.
Yeah.
Same to you, sir. Thank you.
Happy Navaratri.
So we are at the end. So all the participants, we will be sending you the e-certificates maybe in a week's time. And along with that, we will be sending you the PDF of the training manual. And the video link will already Dr. A.K. Singh has shared in the chat box. It will be shared through email also as per your registered email ID. Thank you one and all for being with us for 3 days. Thank you, sir.
Thank you. Thank you. Thank you. Thank you.
Thank you, Sanjay Arora, sir. Thank you very much.
Thank you. Thank you, sir.
Thank you, sir.
so much, sir.
Thank you.
Thank you very much, participants. Thank you.
So I will be ending the meeting. We are scheduling another training in October last week. We will be proposing that soon. It will be on the resource conservation and management. All the participants will be informed about any of the activities in future also. Thank you.
Thank you, Dr. Arora. Thank you.